Imagine you are standing in front of a stone, not a pebble, not a boulder you could tip with your shoulder on a good day. A stone the size of a house. A stone that weighs more than a fully loaded Boeing 747. A stone that was cut from a quarry 20 miles away, moved across uneven terrain, lifted to a precise height, and set into position with tolerances so tight you cannot slide a sheet of paper between the joints. Now imagine you did that 800 times. Without a wheel, without iron tools, without a crane, a pulley, a diesel engine, or a road. That is what the builders of the Great Pyramid accomplished. And that is only one site on a planet covered with these monuments. Stonehenge, Tiwanaku, the megalithic temples of Malta, the Osirian Abydos, Puma Punku in Bolivia, Easter Island, Sacsayhuaman in Peru, where stones weighing more than 100 tons were fitted together so perfectly that the joints look machined. We call these structures ancient mysteries. We write academic papers about ramps and sledges and thousands of laborers pulling ropes in the Egyptian sun. We nod along to the explanations. But the explanations have never fully added up. And deep in mythologies of the very people who built these monuments, in the oral traditions, the sacred texts, the legends passed down across centuries, there's a story that historians have consistently refused to take seriously. The story says the stones did not need to be dragged. The story says they moved on their own. And the story says they moved because of sound. Let us begin with a number. 4.8 million tons. That is the estimated total weight of stone in the Great Pyramid of Giza. 2.3 million individual blocks. The average block weighs 2.5 tons. Some weigh 80. The granite blocks inside the King's Chamber, transported from a quarry in Aswan 500 miles to the south, weigh up to 70 tons each. 70 tons per block. The Aswan granite quarry is still there. You can visit it. And in that quarry, there's an unfinished obelisk that was abandoned mid-cut around 1500 BC, likely because a crack appeared in the rock. If it had been completed and transported to its destination, it would have weighed around 1,200 tons. For context, the largest modern cranes in the world max out at around 3,000 tons under absolute ideal conditions, with modern steel cables, hydraulic systems, and GPS positioning. Ancient Egyptians were operating with copper tools and human muscle. Mainstream archaeology has spent 2 centuries trying to solve this problem with engineering. The leading theory is a combination of sledges, water-lubricated pathways to reduce friction, and ramps, either straight external ramps or internal spiral ramps cut into the pyramid as it rose. Workers would haul the stones on these pathways using ropes and manpower, teams of perhaps 20 to 40 men per block. This model is coherent, and there is genuine evidence for parts of it. A tomb painting at Deir el-Bersha from around 1880 BC shows a large statue being hauled on a sledge, with a figure at the front pouring liquid onto the path ahead. This is real. This happened. But here is where the model starts to strain. The internal ramp theory, proposed by French architect Jean-Pierre Houdin in 2007, requires the Egyptians to have understood structural engineering at a level of sophistication that the model assumes they did not possess in other areas. The external ramp theory requires a ramp that, for the upper sections of the pyramid, would have needed to be longer than the pyramid itself to maintain a workable angle, and would have required more material to build than the pyramid it was meant to service. And then there are the tolerances. The casing stones of the Great Pyramid, the outer limestone blocks that once gave it smooth gleaming sides visible from the moon, were fitted with joints no wider than 0.5 millimeter. Modern stonemasons working with powered equipment struggled to achieve this. The ancient Egyptians achieved at scale, in a desert, 3,000 years before the Common Era. Engineer Chris Dunn, who spent years analyzing the pyramid from a mechanical standpoint, found evidence of machining marks on granite surfaces inside the pyramid that, in his assessment, indicated tools rotating at speeds and with cutting precision that no hand tool of that era could have produced. His conclusions are controversial. Egyptologists dispute them, but his measurements have never been successfully explained away. And here is what no one disputes. We cannot replicate what they built. In 1999, a team of engineers and archaeologists, as part of a documentary project, attempted to build a small pyramid using only the tools and methods that mainstream archaeology assigns to the ancient Egyptians. They had modern researchers, unlimited labor volunteers, and total logistical support. They failed to come close to the precision of the original. After several days, the experiment was quietly abandoned. Now here is where the story takes a turn. Because the question of how the pyramids were built is only the most famous version of a problem that exists at dozens of sites around the world. And when you start mapping those sites against each other, something strange emerges. The stones are not just large. The stones are often in places they have absolutely no right to be. The Temple of Baalbek in Lebanon contains 3 stones in its foundation, known as a trilithon, each weighing approximately 800 tons. They sit 19 meters above ground level. The quarry they came from is a quarter-mile away, and to reach the temple site, they had to travel uphill. One stone, still partially buried in the quarry, weighs an estimated 1,650 tons. It is called Hajar el-Hibla, which translates as a stone of the pregnant woman, and it was never finished, never moved. Nobody has ever explained how the 3 that were moved actually got there. In Peru, the fortress of Sacsayhuaman sits above the city of Cusco, an altitude of over 3,700 meters above sea level. Its walls are built from polygonal limestone blocks, some weigh more than 100 tons, that fit together without mortar in a jigsaw-like interlocking pattern that has survived multiple earthquakes powerful enough to collapse Spanish colonial buildings built on the same site. The Spanish, when they arrived, were so baffled by the construction that several of their chroniclers attributed it to demons, or to giants, or, in one account written by a Spanish priest named Cieza de Leon in the 1500s, to quote the most widely cited passage, something that is difficult to understand when one considers that there were no machines. The Spanish were not wrong to be baffled. We still are, and running beneath all of this mystery, the deepest and most stubborn question of ancient architecture is not simply how did they move these stones. The deeper question is, what do they know that we do not? Because every civilization that built these structures left behind, alongside the stones themselves, a tradition, a mythology, a set of stories about how the work was accomplished. And in those stories, across cultures that never contacted each other, across centuries and continents and language groups, the same image keeps appearing. Sound, priests chanting, drums striking stone, metal rods struck against rock faces, notes held until the stone rises. It is in the Egyptian texts. It is in the Bolivian oral tradition. It is in the Norse mythology, where the god Odin is said to know songs that could move mountains. It is in the Jewish tradition of the shamir, a worm or stone or device. The descriptions vary, that could cut rock without iron tools, that some scholars believe was an acoustic instrument. It is in the Welsh Merlin legends, where Stonehenge was transported from Ireland to England not by force, but by the wizard's knowledge, which in older versions of the legend is described as the knowledge of sound. Now, here is what makes this more than mythology. Modern physics has proven, beyond any doubt, that sound can levitate objects. It is not a theory. It is not fringe science. It is a reproducible laboratory phenomenon that has been demonstrated at universities in the United States, Japan, Switzerland, and Germany. In 2015, researchers at the University of Bristol in England used acoustic standing waves to levitate and move small objects in three-dimensional space with no physical contact. In 2017, a Japanese team at the University of Tokyo demonstrated acoustic levitation that could not only lift objects but rotate them and translate them horizontally along a precise path. The forces involved at these experimental scales are tiny, the objects being levitated weigh fractions of a gram. But the principle is real. Sound creates pressure. Pressure can oppose gravity. The question is not whether acoustic levitation exists. The question is whether it can be scaled. And the question beneath that question is, has it been scaled before? Because if you read what the legends say carefully, if you strip away the poetry and mythology and the religious framing, what you are left with sounds very much like a description of exactly that. The stones, according to the legends, did not float gently like bubbles. They moved in specific ways, along specific paths, when specific sounds were produced at specific frequencies. The accounts are operational. They read less like mythology and more like something else entirely. They read like instructions. And the fact that we can no longer follow those instructions might not be because they were invented. It might be because at some point in the deep past, something was lost. Something that built a world we cannot build today. We are going to spend the next hour and a half trying to find it. Every civilization on Earth has myths, creation stories, flood narratives, gods who descend from the sky, heroes who slay monsters, kings who receive wisdom from fire. We are a species that reaches for the supernatural when the natural world outpaces our ability to explain it. That is not ignorance. That is the human mind doing exactly what it evolved to do. But there is a category of myth that deserves a second look, not the myths that explain what cannot be understood, the myths that describe what was witnessed. There is a difference between a story that says the sun god rides a chariot across the sky because no one knew what the sun actually was, and a story that says a group of priests stood in formation around a massive stone, struck metal instruments against the ground, held a specific sequence of tones, and watched the stone lift from the earth. The first is metaphor. The second is an account. And when the same account surfaces independently across a dozen civilizations that never communicated with each other, across thousands of years and thousands of miles, the rational response is not to dismiss it. The rational response is to ask, what were they all seeing? Let us start in Egypt. The word is Heka. It is one of the oldest words in the Egyptian language, and it translates loosely as magic. But magic is a wrong word, because in modern English magic implies illusion, tricks, the supernatural. In the Egyptian worldview, Heka was not supernatural at all. It was a fundamental force of the cosmos, as real as gravity or light. It was the animating power of creation, the force through which the creator god Adam first brought the universe into existence. And Heka operated primarily through sound. The Egyptian creation myth does not describe a god who built the universe with his hands. It describes a god who spoke it into being. The primordial mound rising from the chaos waters at the beginning of time was called into existence through the divine utterance, the spoken word, the sacred vibration that preceded all physical reality. This is not unique to Egypt. The opening of the Gospel of John in the Christian tradition echoes it directly. In the beginning was a word. The Vedic tradition in India calls it Nada Brahma, the universe as sound. The Norse say Odin sang the world into shape. But in Egypt, Heka was not merely cosmological. It was practical. The priests of ancient Egypt were divided into specific castes with specific functions. Among these castes were the Kureb, the lector priests, who were responsible for reading and reciting the sacred texts during rituals and ceremonies. Their role was not simply liturgical. According to the Egyptian texts themselves, the Kureb possessed technical knowledge of sound that allowed them to do things in the physical world that ordinary people could not do. The texts speak of words of power that can move objects, alter states of matter, and affect physical reality directly. Now, mainstream Egyptology reads this as religious metaphor. The priests are speaking about spiritual transformation, not physical mechanics. That is a reasonable interpretation. But here is what makes the acoustic interpretation harder to dismiss entirely. In the mid-19th century, a French Egyptologist named Auguste Mariette discovered a collection of manuscripts in a Coptic monastery near Cairo. Among them was a text, its origins and precise age debated, that described in unusual detail the construction of the pyramids. According to this text, the builders did not transport the stones by brute labor. The text describes a builder striking stones with a rod or what it calls a metal of the sun, after which the stones would rise and travel through the air to their appointed places along a predetermined path marked with papyrus. Metal of the sun is a recurring term in ancient Egyptian texts. Some scholars identify it with gold, others with a semi-mythical material called orichalcum. But what is interesting about this account is not the material. It is the mechanism, a rod, a strike, a vibration, a path. That is not a creation myth. That is not an allegory about the soul's journey through the afterlife. That is a description of a technique. And it does not stand alone. The Arab historian al-Makrizi, writing in the 14th century of the Common Era, compiled a history of Egypt that drew on much older sources, some of which no longer exist. In his account of pyramid construction, he references a tradition that the pyramids were built by a pre-flood king named Surid, who erected the monuments as repositories of knowledge and treasure before a great catastrophe. According to the tradition al-Makrizi was drawing on, the stones were moved through an acoustic method. through the use of sound and vibration applied to the rock face before transport. Al-Makrizi himself is skeptical of parts of this tradition. He is not trying to sell a mystery. He is reporting what older sources said. And the same story, with striking consistency, appears in a work of the Arab writer known as Paulinus, whose name is the Arabiized form of Apollonius of Tyana, a Greek philosopher and traveler of the 1st century of the Common Era. Paulinus claimed to have discovered a sealed underground chamber beneath a statue in Tyana, in what is now Turkey, where he found a seated old man holding a tablet of green stone. The tablet, which became known as the Emerald Tablet, contained instructions for working with the fundamental forces of nature. Among these instructions, Paulinus claimed, were methods for aligning vibration with gravitational force to move and shape matter. The Emerald Tablet is one of the most replicated documents in the history of alchemy and early science. Isaac Newton owned a copy and translated it into English himself. Whether it is genuinely ancient or a medieval fabrication remains disputed, but the acoustic tradition it is associated with predates Paulinus by centuries. Now let us leave Egypt and travel roughly 10,000 kilometers to the southwest. In Bolivia, on a high plateau nearly 4,000 meters above sea level, sits one of the most mysterious sites on Earth, Tiwanaku, or, in the modern Bolivian spelling, Tiwanaku. It is a city that the Inca, when they arrived in the region around the 12th century of the Common Era, did not claim to have built. The Inca were extraordinary builders. Sacsayhuaman and Machu Picchu, the entire infrastructure of the Andean Empire, these were their works. But when they encountered Tiwanaku, they did something unusual for an imperial culture. They said it was not theirs. They said no human hands had built it. According to Inca oral tradition, Tiwanaku was a place where the creator god Viracocha first made human beings from stone. The city itself was raised in a single night, before the first sunrise, when Viracocha sang the stones into their positions. Sang them. Now, the Inca were sophisticated people. They built an empire of 12 million people without a written language, managing it entirely through an oral and nautical recording system called Quipu. They were not a civilization that confused metaphor with literal event in a naive way. When they said a thing happened, they had a tradition of precision in the telling. What they said about Tiwanaku is that the construction was accomplished through sound, through specific tones produced by Viracocha himself, the god who came from the lake after a great flood, who carried a staff and wore a shining robe, who was described as having a long beard, which is unusual in South American iconography because the indigenous populations of the Andes have little facial hair. The bearded god who sang cities into existence. The stones at Tiwanaku are extraordinary. The Puma Punku platform, one section of the larger Tiwanaku complex, contains H-shaped blocks of andesite and sandstone that weigh up to 130 tons and were transported from a quarry at least 10 kilometers away, across a lake and through highland terrain. Their surfaces are machined or worked to a degree that appears machined, with interior cuts and channels that repeat to precise tolerances across multiple blocks, suggesting they were created with a template or with a consistency of tool application that hand chiseling does not easily explain. But there is something else about Puma Punku that is rarely discussed in popular accounts. The blocks are not simply large. They are acoustically shaped. Researchers who have studied the acoustic properties of the site have noted that the H-shaped blocks, when struck, produce resonant tones. The cavities and channels cut into them act as resonating chambers. The stone itself, the specific andesite used, has a density and crystalline structure that makes an unusually efficient acoustic material. Some of the blocks, when you strike them with a wooden mallet in the right location, ring like a bell. This could be coincidence, but it is also exactly what you would expect if the blocks have been designed with acoustic function in mind. The Bolivian ethnomusicologist Arnaldo Ortega spent years in the 1980s and 90s documenting the oral traditions of the Aymara people, the indigenous group whose ancestors the Inca claimed had not built Tiwanaku, but whose culture had been formed around it for millennia. Ortega recorded accounts, passed down across generations in the Aymara oral tradition, that describe a time when large stones could be made to move through the application of specific rhythms played on drums and wind instruments made from bone and reed. The accounts he recorded were not presented as mythology. They were presented as lost knowledge, as something that once existed and had been forgotten. Ortega's work is not widely cited in mainstream academic literature. It was not published in a major journal. It was compiled in a collection of regional ethnographic studies that reached a limited audience. But the pattern it contributes to is becoming impossible to overlook. Now we go north and east, high into the mountains of Asia. In Tibet, in 1939, a Swedish physician named Dr. Jarl, who was working with a medical mission associated with Oxford University, reported witnessing something that he spent the rest of his life struggling to explain. He was traveling through a remote valley in the Himalayan foothills when he was taken by his Tibetan guide to observe a ceremony that was happening on a high cliff face. At the base of the cliff, a group of monks were engaged in what appeared to be a construction project. They were attempting to move large stone blocks up the cliff to a location approximately 250 meters above. But they were not using ropes. What Jarl described was this. The monks arranged their instruments in an arc behind the stones. The arc consisted of 19 instruments in total. There were 13 large drums, each roughly 1.5 meters in diameter, mounted on heavy wooden frames and angled upward toward the cliff face. There were 6 trumpets of varying lengths, some long enough that they required 2 monks to hold them upright. The monks began to play, beginning slowly, building in rhythm and intensity over a period of about 4 minutes. And then, according to Jarl's account, the stone block vibrated, and rose, and traveled in a curved trajectory up the face of the cliff, reaching the construction platform at the top in approximately 3 to 4 minutes. The stone weighed, by Jarl's estimate, approximately 1.5 tons. Now, this account must be treated carefully. Jarl's story did not reach a wide audience until decades after his death, when it was referenced by the New Zealand researcher Bruce Cathy in a book published in 1971. Cathy claimed to have obtained Jarl's own film footage of the event, footage that Jarl had reportedly been asked by Oxford to suppress. The film has never surfaced publicly. The account is therefore unverified. It is a second-hand report of a deceased man's claimed first-hand experience, filtered through a researcher with his own theoretical agenda. These are significant caveats. Any honest treatment of this story must acknowledge them. But here is what makes a Jarl account remarkable, even if you take it only as a constructed story rather than an eyewitness report. The specific details it contains, the angle of the instruments toward the stone, the arc formation behind the object rather than around it, the slow build to a target frequency, the curved trajectory of the stone rather than a straight vertical lift. These details are consistent with how acoustic levitation actually works in a laboratory setting. You do not simply point a speaker at a rock and shout at it. Acoustic levitation requires the creation of a standing wave, a pressure node, a specific spatial arrangement of sound sources that creates a zone of constructive interference directly above and around the target object. The geometry Jarl described, instruments arranged in an arc, angled upward at the stone, building to a frequency, matches the geometry you would design if you understood the physics of standing wave formation. Either Dr. Jarl witnessed something real, or whoever constructed this story in the late 20th century had an unusually detailed understanding of acoustic physics. Neither option is comfortable. Now consider what we have. Egypt, Bolivia, Tibet, 3 civilizations, 3 separate traditions, 3 independent descriptions of stones being moved through sound. And they are not alone. In the Norse Eddas, the compilation of Viking mythology written down in the 13th century from oral traditions dating back centuries further, the god Odin is said to possess 18 specific songs, detailed in the poem Havamal. The 15th of these songs is described as capable of lifting and moving stones and trees, not metaphorically. The Eddas are generally quite specific when they mean metaphor and quite specific when they mean a literal act. The 15th song is presented as a practical tool. In Welsh tradition, the legend of Merlin building Stonehenge, which in its earliest versions predates the French chivalric romance tradition that gave us the more familiar Arthurian cycle, describes Merlin transporting the stones from Ireland through his knowledge of the secret properties of the stones themselves. In Geoffrey of Monmouth's 12th century account, which draws on much older Welsh sources, Merlin tells Uther Pendragon that the stones must be transported using wisdom, not labor, because there's a force within the stone that only the right application of knowledge can release. Later versions replace wisdom with magic and magic with muscle, But in the oldest surviving versions, the mechanism is knowledge, not supernatural power. And in the Jewish tradition, we have the shamir. The shamir is mentioned in the Talmud and in numerous rabbinic texts as a tool used to cut the stones of Solomon's temple. This is significant because Jewish law, as described in Exodus, expressly forbade the use of iron tools in construction of the temple altar. No iron shall be lifted upon them, says the text. The rabbinical explanation for this prohibition is often framed in terms of iron being associated with warfare, and therefore impure for sacred space. But the practical question it raises is, if not iron, then what? The shamir, the texts say, a worm or a stone or a device. The descriptions genuinely vary. That could cut stone without iron. That could cause stone to split and shape itself with the application of the shamir alone. Some descriptions suggest it emitted a vibration. Some say it worked by sound. Some say it needed to be contained in a lead box because its power could not be contained otherwise. Lead, incidentally, is an excellent acoustic dampener. The shamir disappeared when the temple was destroyed. No one knows what it was, but the description in the text is consistent. It worked on stone through a non-contact mechanism that involved vibration. Now, here is the critical observation. If these traditions were purely mythological inventions, you would expect them to vary freely. You would expect some cultures to say the gods use fire, others to say the gods use water, others to say the gods use wind. The specific mechanism would be incidental, because the point of the myth would be to convey power, not technique. But the traditions do not vary freely. Across Egypt, Bolivia, Tibet, Scandinavia, Celtic Britain, and ancient Israel, the same specific mechanism appears. Sound, vibration, frequency, applied to stone, producing movement. That convergence requires an explanation. One explanation is cultural diffusion. Perhaps there was an original source for this idea, a single tradition that spread outward across the ancient world through trade routes and migration, and each culture adapted it to their own mythology. If that is the case, then the original source of the idea was either a real practice or a fiction so compelling that it spread to every corner of the ancient world and was adopted into the foundational mythology of civilization after civilization. Another explanation is independent invention. Perhaps these different cultures, having all observed some phenomenon that sound can do to matter, independently constructed similar mythological frameworks around it. And the third explanation is the one that makes historians the most uncomfortable. Perhaps they were all remembering the same thing. Not a myth, not a metaphor, not a narrative convenience. A technology that once existed on this planet, that built the monuments we cannot explain, and that was lost. And if it was lost, then the question of where it came from in the first place becomes the most important and unsettling question in the history of human civilization. We are not going to answer that question yet, but we are going to build toward it. Because before we can ask where this technology came from, we need to understand what it actually is. We need to strip it out of mythology, lay it on a laboratory table, and look at what physics says about the relationship between sound and matter. And what physics says is going to surprise you. Berlin, 1787. A German physicist named Ernst Chladni stands in front of an audience of natural philosophers, scientists, and curious aristocrats. He has brought with him a simple apparatus, a thin metal plate, fixed at its center to a wooden post, a violin bow, and a handful of fine sand scattered across the surface of the plate. He draws the bow slowly across the edge of the plate. The room fills with a tone, clear, sustained, resonant, and the sand moves, not randomly, not chaotically. The grains skitter and slide across the surface, but they do not slide in all directions equally. They are being pushed away from certain regions of the plate and drawn together at others. Within seconds, the formless scatter of sand has organized itself into a precise and intricate geometric pattern. Straight lines, curves, intersections, symmetries that look as though they were drawn with a compass and straight edge. Chladni changes the frequency. The pattern dissolves. The sand scatters. A new tone and a new pattern emerges. Different, equally precise, equally geometric. The audience is silent. What Chladni has just demonstrated is something that will take another 200 years to be fully understood. But what the people in that room are seeing with their own eyes is already clear enough to shake something loose in their understanding of the world. Sound does not simply travel through matter. Sound organizes matter. Let us understand what is actually happening in the Chladni experiment, because it is the foundation of everything that follows. When you draw a bow across the edge of a metal plate, you cause the plate to vibrate. Vibration means movement. Rapid, cyclical, back and forth movement of material itself at a specific frequency, a specific number of oscillations per second, measured in a unit we call hertz. 1 hertz means 1 complete oscillation per second. The note A above middle C, the standard tuning pitch for musical instruments, is 440 hertz, meaning the material producing that note moves back and forth 440 times every second. When a plate vibrates, it does not vibrate uniformly across its entire surface. Different regions of the plate move in different ways and at different amplitudes. Some regions are vibrating intensely, moving back and forth with maximum displacement. These are called antinodes. Other regions are barely moving at all. These are called nodes. The sand moves toward the nodes. Specifically, it is pushed there by the vibrating regions, the antinodes, which in effect shake the sand off their surfaces, depositing at the boundaries, the still points, the nodes. The pattern that results is a map of the invisible vibrational structure of the plate. It is a visible fingerprint of the sound. Now here is what makes this significant. The patterns are not arbitrary. For any given material, any given size and shape of plate, a specific frequency will always produce the same pattern. Always, every time, without exception. The relationship between frequency and pattern is not random. It is lawful. It is determined entirely by the physical properties of material and by the mathematics of wave interference. Sound is not just noise. Sound is structure. Sound is order. Sound, at the right frequency applied to the right material, does not create chaos. It creates geometry. Chladni published his findings in a book in 1802. Napoleon Bonaparte was so impressed by the demonstration that he offered a prize of 3,000 francs to anyone who could produce a mathematical theory explaining the patterns. A French mathematician named Sophie Germain eventually won that prize, though it took her 3 attempts and 15 years. The mathematical framework Germain developed became foundational to modern structural engineering, acoustics, and material science. Every time an engineer today tests the resonant frequencies of a bridge or an aircraft wing to make sure it will not shake itself apart, they are using principles that trace back to a man drawing a bow across a sand-covered plate in a Berlin parlor in 1787. But the science did not stop with Chladni. Fast forward to 1950. A Swiss physician and natural scientist named Hans Jenny begins a series of experiments that he will continue for 20 years and eventually publish under the name cymatics, from the Greek word chyma, meaning wave. Jenny's experiments start where Chladni's left off, but go dramatically further. He builds devices he calls tonoscopes, instruments that can transmit precise vibrations into a variety of materials, not just metal plates. He works with water, oil, liquid mercury, sand, iron filings, viscous paste, biological fluids, and dozens of other substances. And what he finds is extraordinary. Every substance, when subjected to specific sound frequencies, organizes itself into complex, stable, 3-dimensional structures. Not just 2-dimensional surface patterns like Chladni's sand figures, but genuine 3-dimensional forms, some of which rotate, some of which pulse rhythmically in time with the applied sound. When the frequency changes, the form dissolves. A new frequency produces a new stable form. At lower frequencies, the patterns are relatively simple, concentric rings, basic geometries. As frequency increases, the patterns become more complex, more facets, more symmetry axes, more intricate internal structure. And here's a detail that tends to stop people cold when they encounter for the first time. At certain specific frequencies, water and viscous fluids spontaneously form shapes that are botanically and biologically recognizable. Branching forms that look like neurons or river deltas. Cellular structures that resemble tissue seen under a microscope. Hexagonal tilings that look identical to a bee's honeycomb or the basalt columns of the Giant's Causeway in Ireland. Nobody designed these forms. Nobody programmed them. They emerge spontaneously from the interaction of sound and matter, governed entirely by frequency and the physical properties of material. Jenny spent the last years of his life arguing that cymatics represented a fundamental discovery about the nature of reality. That form, biological and physical form, might not be the product of random chance and chemical combination, but of resonance, of vibration, of sound working on matter at the most fundamental level. This is a claim that mainstream science has not accepted. The leap from sand patterns on a plate to the origin of biological morphology is, to put it charitably, very large. But what Jenny undeniably demonstrated in thousands of documented and photographed experiments over 2 decades is the sheer formative power of sound applied to matter. His experiments are repeatable. They have been replicated in dozens of laboratories worldwide. The images are real. Sound shapes matter. This is not in dispute. The question is, how much matter? And how forcefully? This is where we move from the visible elegance of cymatics into the harder, more mathematical world of acoustic levitation. The fundamental principle is this. Sound is a pressure wave. It moves through air or water or solid material as a series of compressions and rarefactions. Regions where the molecules are packed together and regions where they are spread apart. These pressure variations are not metaphorical. They are physical forces. They push and pull on objects in their path. At the sound levels we encounter in everyday life, these forces are tiny. A loud concert, a jet engine at close range. These produce sound pressures that you can feel on your body, but that cannot lift objects against gravity. But there's a phenomenon called acoustic radiation pressure that operates differently from the oscillating push-pull of a passing sound wave. When a standing wave is established between 2 surfaces or between 2 carefully positioned sound sources, something unusual happens. A standing wave is created when a sound wave and its reflection interact in a way that produces stable regions of maximum and minimum pressure that do not travel. They stand in fixed positions in space. The points of minimum pressure in a standing wave are the pressure nodes, and these are remarkable locations. At a pressure node, the acoustic radiation pressure acts not as a passing push, but as a sustained, stable, 3-dimensional cage of force. Objects placed at these pressure nodes are held there, supported from all sides by converging pressure differentials, suspended against gravity, without any physical contact. This is acoustic levitation, not science fiction, not ancient myth. Physical fact, demonstrated in laboratories on every continent. In 2013, a team at Argonne National Laboratory in the United States published a paper demonstrating acoustic levitation of liquid droplets and small solid objects. In 2015, the University of Bristol team previously mentioned demonstrated not just levitation, but controlled 3-dimensional movement of levitated objects using phase arrays of ultrasonic transducers, speakers operating at frequencies above the range of human hearing, that could be steered electronically to move the pressure nodes around in space. The levitated object followed. In 2017, a team at the University of Tokyo went a step further. They demonstrated acoustic levitation using audible frequency sound, not ultrasound, and showed that by using multiple speakers arranged in a specific geometric configuration and carefully controlling the phase relationships between them, they could create and manipulate stable pressure nodes large enough to levitate objects significantly larger than the wavelength of the sound being used. That last detail matters enormously. One of the engineering challenges in acoustic levitation is that the maximum size of the levitated object is generally limited by the wavelength of the sound. Lower frequency sound has a longer wavelength, and longer wavelength means you can potentially levitate larger objects. But lower frequency sound also requires more energy and more precise phase control between multiple sources. There is a direct, mathematically describable relationship between the size of the object you want to levitate, the frequency you need to use, the number of sound sources required, their geometric arrangement, and the total acoustic power necessary. Let us do an honest version of the math. A standing wave at a frequency of 100 Hz, which is a low bass tone audible to humans, has a wavelength in air of approximately 3.5 meters. The theoretical maximum object that could be held in a pressure node at that frequency is on the order of half a wavelength, roughly 1.5 to 2 meters. The acoustic pressure required to support an object against gravity depends on the object's density. For granite, which has a density of approximately 2,700 kilograms per cubic meter, levitating a block 1 meter on each side, a mass of approximately 2,700 kilograms, 2.5 to 3 tons, would require acoustic pressure in the range of several hundred kilopascals. For reference, the pressure at the bottom of 10 meters of water is approximately 100 kilopascals. We're talking about pressure levels that, in air, correspond to sound intensities that would be physically destructive to human tissue. This is where the standard dismissal of the acoustic levitation theory of ancient construction comes from, and it is a legitimate objection. The energy requirements for levitating multi-ton stones in air at human audible frequencies are, using conventional acoustic physics, enormous, far beyond what drums and voices and metal rods could plausibly produce. But here is where the dismissal runs into several serious complications. The first complication is resonance. Every physical object has what is called a natural resonant frequency, or a set of them. This is the frequency at which the object vibrates most efficiently and with the greatest amplitude in response to a given input of energy. When you hit a wine glass and it rings, the note it produces is its resonant frequency. Push energy into a system at its resonant frequency, and you get a dramatically amplified response, far beyond what you would get from the same energy input at a non-resonant frequency. This is the principle behind the famous phenomenon of the singer who can shatter a wine glass. The voice does not need to be impossibly loud. It needs to be precisely on frequency. Once the glass is vibrating at its own resonant frequency, a relatively modest continued input of energy at that frequency will amplify the vibration until the material exceeds its tensile strength. Resonance can be extraordinarily powerful with very modest energy inputs. Now, granite, limestone, and andesite, the 3 stones most commonly used in the great ancient monuments, all have measurable and specific resonant frequencies. These frequencies depend on the size, shape, and density of the individual block. They are not fixed universally across all granite, but for any given shape block, the resonant frequency is determinable. If you could find and apply the exact resonant frequency of a specific stone block, the energy required to produce dramatic vibrational effects in that stone would be radically lower than the calculations I just described would suggest. You are not fighting the stone's inertia. You are working with it. You are feeding energy into a system that is already primed to accept and amplify it. This distinction between brute acoustic force and targeted resonant application is critical, and it is the distinction that the legends, interestingly, consistently describe. They do not describe shouting at stones. They describe specific frequencies, specific instruments, specific tones for specific stones. Selectivity, precision, the application of exactly the right sound. The second complication is the medium. Everything I described about the energy requirements for acoustic levitation assume that the medium between the sound source and the stone is air. But air is a very inefficient medium for transmitting acoustic pressure to a dense solid object. The acoustic impedance mismatch between air and granite, the degree to which energy is reflected rather than transmitted at the boundary, is enormous. Something like 99% of acoustic energy in air is reflected at the surface of granite, rather than entering it. But what if the ancient builders were not working through air? What if the transmission medium was water, or stone, or some coupling material we are no longer aware of? Acoustic energy transmits through water and through solid materials at far greater efficiency than through air. Ultrasonic cleaning tanks, the devices used to clean delicate instruments and jewelry, work on exactly this principle. The object being cleaned is immersed in liquid, and the acoustic waves are transmitted through the liquid directly into material, creating powerful internal vibrations with relatively modest energy input. Several researchers studying ancient construction have noted that many megalithic construction sites show evidence of proximity to or deliberate flooding of their working areas during construction phases. The moat-like channels around certain Egyptian temple complexes, the hydraulic evidence at the Osirian, the proximity of virtually every Andean megalithic site to water features. This might be coincidence, or it might suggest that water was not incidental to the construction process, but integral to it. The third complication is the most important and the most difficult to test. Everything we know about acoustic levitation is based on experiments conducted at small scales with off-the-shelf technology. We have never attempted to build a large-scale, purpose-designed acoustic levitation system using materials optimized for the task. We have never arrayed dozens of high-power, low-frequency acoustic sources in precise geometric configurations that will produce the strongest possible standing wave fields of the scale of a multi-ton object. We have never tried, which means that when we say acoustic levitation of a multi-ton stone is impossible, what we are actually saying is something more modest. We are saying we have not done it. We are saying our current best approximation of the physics suggests it would be very difficult with conventional approaches. That is not the same as impossible. And history has an awkward habit of reclassifying the impossible as the merely difficult, and the merely difficult as the routine, given sufficient understanding of the underlying principles. There is one more piece of science that needs to be on the table before we move forward. It was discovered by an American acoustic engineer named Tim Daly working with a team at a government research facility in the 1990s. Their work was part of a classified program examining non-lethal acoustic weapons and was only partially declassified in the early 2000s. What Daly's team found, working with high-intensity, low-frequency sound applied to large masses of stone, was a phenomenon they called acoustic decoupling. When you apply a specific combination of frequencies to a large stone block, a primary frequency at or near the stone's resonant frequency, combined with lower secondary frequency at the resonant frequency of the stone's interface with whatever surface it is resting on, the effective friction between the stone and the surface drops dramatically, not to zero, but by a measurable, significant factor. A stone that would require, say, 500 kilograms of horizontal force to slide along a surface normally might require only 50 kilograms to slide when the right acoustic decoupling frequencies are applied, a factor of 10 reduction in required force. Daly's team did not claim to have achieved levitation. They achieved something more modest and perhaps more practically significant. They showed that the right application of sound to stone could reduce the effective friction and inertial resistance of a large mass to a degree that would make moving it dramatically easier for a relatively small labor force. You do not need to levitate a 100-ton stone if you can make it effectively behave like a 10-ton stone. The legends may be reporting this phenomenon in the most dramatic and memorable terms available to people who witnessed it, but had no scientific framework for explaining it. A stone that should not move and then moves almost effortlessly would look, from the outside, very much like a stone that is floating. Here is where we stand. Sound organizes matter at visible scales. Cymatics proves it. Acoustic levitation is real and reproducible. The physics are established. The energy requirements for large-scale acoustic levitation are high but not infinitely high, and they are dramatically reduced by resonance targeting, by efficient transmission media, and by acoustic decoupling phenomena. The gap between what we can do in a laboratory today and what the legends describe is real. It is significant, but it is not infinite. And here's the question that drives the next section of this documentary. If the ancient builders understood acoustic physics at the level the legends suggest, what evidence would they have left behind in the structures themselves? Because here's the thing about sound. It leaves fingerprints. Specific resonant frequencies, specific dimensions, specific materials chosen not only for their structural strength, but for their acoustic properties, specific geometric arrangements that correspond not to aesthetic choices or astronomical alignments, but to the mathematics of standing wave formation. If the ancient builders designed their monuments with acoustic principles in mind, then those principles should be readable in the stones today, not in the mythology, not in the legends, in the physical dimensions and material choices of the buildings themselves. And when researchers have actually measured those dimensions and those materials, what they have found is deeply unsettling. We begin at the most famous construction site on Earth, the Great Pyramid of Giza. You enter the Great Pyramid through a narrow opening on its north face. The passage is not welcoming. It is roughly 1 meter wide and 1.2 meters tall, which means that for most adults, entry requires bending almost double. The stone walls press close on both sides. The air is cool and dry and still in a way that feels different from ordinary stillness, as though the air inside has not moved in a very long time and has grown dense with that immobility. You descend at a steep angle, 26 degrees below horizontal, for approximately 30 meters. Then the passage levels off. Then it splits. One branch continues downward into a roughly cut chamber beneath the pyramid that was never finished and whose purpose remains unknown. The other branch reverses and climbs upward into the interior of the pyramid at the same 26-degree angle, but now ascending. This ascending passage leads, eventually, to what the Arabs who first forced their way inside around the year 820 of the Common Era called Beit al-Maut, the House of the Dead. We call it the King's Chamber. And what happens inside the King's Chamber when you make a sound is not what you would expect. In 1997, an acoustic engineer and inventor named John Stewart Reed arranged access to the King's Chamber for a series of experiments he had been planning for years. Reed was not an Egyptologist. He was not an archaeologist. He was a professional acoustic engineer with a serious and long-standing interest in cymatics, the science of visible sound patterns that we discussed in the previous chapter. He brought specialized equipment, a speaker, a tone generator capable of producing precise frequencies across a wide spectrum, microphones, and recording equipment. What he found when he began testing the acoustic properties of the chamber changed the direction of his professional life. The King's Chamber is constructed entirely from Aswan granite, not the local Tura limestone used for the pyramid's outer casing and much of its core, but granite transported from a quarry 500 miles south at Aswan, dense and crystalline, with a mean density of 2,690 kilograms per cubic meter. The chamber measures 10.45 meters in length, 5.09 meters in width, and 5.82 meters in height. The ceiling is formed by 5 massive granite beams, each weighing approximately 70 tons, laid side by side across the full width of the chamber. These measurements are not the dimensions of convenience. They are not the proportions of a room designed first for structural integrity and then fitted with function. When Reed began to measure the chamber's natural resonant frequencies, what he found was that the dimensions of the room corresponded, with a precision that he described as extraordinary, to the acoustic wavelengths of a specific set of frequencies. The chamber resonates most strongly at around 111 Hz. 111 Hz is a frequency with a wavelength in air of approximately 3 meters. The width of the King's Chamber is 5.09 meters, which is almost exactly 1 2/3 wavelengths at 111 Hz. The height of the chamber is 5.82 meters, which is almost exactly 1 9/10 wavelengths at the same frequency. These are not random relationships. They are the proportional relationships you would design into a room if you wanted to maximize constructive resonance at that specific frequency. At 111 Hz, the King's Chamber does not simply reverberate like an ordinary room. It resonates. The granite walls, ceiling, and floor absorb energy at that frequency and re-emit it with amplified efficiency. The sound does not decay the way it does in a normal room. It accumulates. It builds. Reed placed a speaker in the chamber and drove it with a sine wave at 111 Hz. The result, by his account, was a physical pressure that could be felt in the chest and skull, a sustained vibration that seemed to come not from the speaker but from the walls themselves, as though the stone were singing. This is not metaphor. Resonance is a measurable physical phenomenon. Stone absorbs and re-emits acoustic energy. The King's Chamber, built from Aswan granite, which has particularly high acoustic efficiency for its density class, behaves at 111 Hz like an enormous tuning fork that has been given its frequency and will not let it go. But Reed discovered something else. Something that, to his cymatic sensibility, was more significant than the resonant frequency itself. Inside the chamber stands the sarcophagus. The granite sarcophagus of the King's Chamber is one of the most enigmatic objects in all of archaeology. It is cut from a single block of Aswan granite, its interior hollowed with an accuracy that, when measured with modern instruments, reveals tolerances of less than 0.5 millimeter on the interior faces. The corners are square to a degree that would challenge a modern machinist. The surfaces of the interior have been polished to a flatness that, in places, approaches optical quality. It is also slightly too large to fit through the entrance passage to the King's Chamber. This means it was placed inside the chamber during construction, before the ceiling beams were laid. Before the room was sealed, the sarcophagus was not carried in. It was built in. Mainstream archaeology interprets this as evidence of careful forward planning by the pyramid's builders, which it certainly is. But it also means the sarcophagus was considered important enough to construct the entire chamber around it, rather than inserting it afterward. Why? If the sarcophagus was simply a burial container, this level of planning and material quality seems excessive. Granite of this precision is extraordinarily difficult to work with. The Egyptians had granite sarcophagi in many tombs that were inserted after the burial chamber was complete. Perfectly functional, much simpler to manufacture. The king's chamber sarcophagus is in a completely different category. When Reed placed the cymatic apparatus, his sound visualization equipment, against the surface of the sarcophagus and drove it with the chamber's primary resonant frequency of 111 Hz. The vibrations in the granite surface produced Chladni figures, the complex geometric sand patterns we examined in the previous chapter, that Reed described as among the most intricate and stable he had ever observed in any material. The sarcophagus, in other words, is an extraordinarily efficient acoustic resonator. Its dimensions, its material, its precise surface finish, all contribute to its ability to hold and amplify a standing wave at specific frequencies with unusual efficiency. Reed stopped short of claiming this proves the sarcophagus had an acoustic function. He is a careful scientist, and he knows the difference between a measurement and an interpretation. But he made a specific and verifiable observation. The acoustic properties of the king's chamber sarcophagus are not accidental byproducts of its construction. They are too precise and too consistent to be incidental. Something about the design of this object was intended to interact with sound in a specific way. The question he could not answer from his measurements alone was, what was that interaction meant to accomplish? Now, let's go back to the chamber itself and look at what sits above the ceiling. Above the 5 granite ceiling beams of the king's chamber are 5 additional chambers, one stacked on top of another, separated by more massive granite beams. These chambers were discovered in the late 18th and early 19th centuries by explorers who forced their way into them through the surrounding masonry. They were named after the explorers and dignitaries of the era: Davison's Chamber, Wellington's Chamber, Nelson's Chamber, Lady Arbuthnot's Chamber, and Campbell's Chamber at the top, which ends in a pointed gable of granite. Mainstream Egyptology refers to these as relieving chambers. The theory is that they exist to distribute the weight of the pyramid above the king's chamber, preventing the ceiling from being crushed by the millions of tons of stone pressing down from above. This theory has been questioned by structural engineers. The distribution of mass above the king's chamber is not uniform in a way that would require 5 separate chambers to manage. One chamber, or a simple pitched roof arrangement, would have achieved the same structural result with considerably less precision work. The 5 chambers together require the cutting and positioning of dozens of additional massive granite beams in a region of the pyramid that no visitor would ever see, with no aesthetic justification, and arguably no structural necessity beyond what simpler alternatives would have provided. In 2003, an American acoustical engineer and sound system designer named Tom Danley proposed a different function for the chambers above the king's chamber. Danley had spent years working with extremely low-frequency sound systems, infrasound, the range below 20 Hz that humans cannot hear but can feel physically. He proposed that the 5 chambers above the king's chamber, with their specific dimensions and their specific arrangement, form a resonating stack that amplifies specific frequencies emanating from below. His analysis suggested the stack is tuned to amplify frequencies in the infrasound range, below human hearing, but producing powerful physical vibration effects at the structural level of the pyramid. The king's chamber plus the 5 chambers above it would, in Danley's model, act as a coupled resonator system of extraordinary power. A coupled resonator system that, when driven at the right frequencies, would cause the entire interior of the pyramid to vibrate. Danley's proposal was not published in a peer-reviewed journal and has not been subjected to formal academic scrutiny. It should be treated as a hypothesis, not a finding. But his engineering credentials are serious, and his reasoning is based on measurable acoustic principles, not speculation. He is describing something that is physically coherent, whether or not it accurately describes a pyramid's intended function. Let us now go to the Grand Gallery. The Grand Gallery is one of the most architecturally spectacular spaces inside the Great Pyramid. It is the ascending passage, enlarged. While the ascending passage is roughly 1 meter wide and 1.2 meters tall, it suddenly opens at a specific point into a space 8.74 meters tall and 46.68 meters long, with core bell walls that step inward as they rise, creating a narrowing trapezoidal cross-section that reaches a ceiling only 1 meter wide at the top. The core-belled ceiling is one of the most sophisticated structural achievements in ancient Egyptian architecture. Each successive course of stone projects inward beyond the one below it, distributing load in a way that allows the tall, narrow space to remain stable without a flat ceiling beam. To construct it required precise understanding of load distribution and stone mechanics. But there is something else about the Grand Gallery that is rarely discussed in tourist guides. Its acoustic properties are extraordinary. The Grand Gallery is, by every measurement that has been taken in it, a natural acoustic amplifier. Its dimensions correspond to those of a tuned resonant chamber for specific frequencies in the low bass and infrasound range. The core-belled ceiling acts as a complex reflector that focuses and intensifies sound waves traveling along the length of the gallery. Sounds made at the bottom of the gallery are amplified and concentrated as they travel toward the top. At the lower end of the Grand Gallery, where it meets a horizontal passage leading to the King's Chamber, there are a series of notches cut into the side walls at regular intervals. 27 pairs of notches on both sides, evenly spaced. Mainstream archaeology has never produced a satisfying explanation for these notches. They are often described as anchor points for scaffolding or ramps used during construction, but the dimensions and spacing do not align with any known construction method. Acoustic researchers who have examined the notches have proposed a different interpretation. The notches are spaced at intervals that correspond to specific fractions of acoustic wavelengths in the frequency range the Grand Gallery amplifies most efficiently. If you were going to mount a series of resonating instruments, bowls, rods, or tubes whose collective vibration would feed energy into the Grand Gallery's resonant frequencies, these notches are where you would put the mounting brackets. 27 of them on each side. The number 111 keeps appearing in the pyramid research. 111 hertz is not just the primary resonant frequency of the King's Chamber. It also turns out to have specific neurological significance that has been independently established by modern brain research. In 2008, researchers at the Minds and Brains Research Institute in Vancouver published a study examining the neurological effects of specific sound frequencies on human brain activity. They found that exposure to sound at 110 to 112 hertz produced a specific and measurable shift in brain activity, a suppression of higher cortical function associated with rational, analytical thinking, combined with increased activity in regions associated with emotional processing, spatial awareness, and altered states of consciousness. The researchers found this effect in controlled laboratory conditions, using subjects who had no knowledge of what frequency they were being exposed to. The effect was consistent and reproducible. 111 hertz does something specific to the human brain. Now, the pyramid's resonance at this frequency could be a coincidence. The chamber's dimensions could have been determined by other factors, and the acoustic result could be incidental. This is absolutely possible. Correlation is not causation, and anyone telling this story honestly must acknowledge that. But here's the full picture of what we are looking at. A chamber built from the most acoustically efficient granite available, transported 500 miles to the construction site. A chamber whose precise dimensions produce a primary resonance at a frequency that has measurable neurological effects on human consciousness. A sarcophagus inside that chamber built with precision tolerances that make it an extraordinarily efficient acoustic resonator. 5 stacked chambers above the main room that a serious acoustic engineer believes form a coupled infrasound amplifier. A 47-meter gallery with core bell walls and evenly spaced wall notches whose spacing corresponds to acoustic wavelengths. All in one building. Is this evidence that the Great Pyramid was designed as an acoustic instrument? As a resonance chamber for producing specific states in the human nervous system? As an acoustic levitation platform for construction process itself? No single piece of this evidence is conclusive. None of it is. But the cumulative weight of it is heavy, and getting heavier as more people measure and analyze the structure with acoustic tools rather than archaeological ones. And then there's the work of Egyptian archaeologist Dr. Abd el-Hakim Hawaiian, who died in 2008. Hawaiian was not a conventional academic. He was a native Egyptian who had spent his life studying the ancient sites and who drew on a tradition of oral knowledge, passed down through specific Egyptian families whose ancestors had been the original priests and caretakers of the monuments. This tradition, which he called the Commission tradition from Kemet, the ancient name for Egypt, contained specific and detailed accounts of what the pyramid was for. According to Hawaiian, the pyramid was not a tomb. He maintained this position adamantly and consistently throughout his career, noting that not a single mummy and not a single piece of funerary goods had ever been found inside the Great Pyramid. It is the only pyramid in Egypt, he argued, that has absolutely no funerary decoration of any kind on any of its interior walls. Every other pyramid is covered in religious texts, images of the afterlife journey, prayers, and spells for the dead. The Great Pyramid has bare walls. It was not built for the dead, according to the tradition Hawaiian inherited. It was built for the living, specifically for initiation, for transformation, for the deliberate alteration of consciousness through acoustic means. Priests or initiates would enter the king's chamber. The acoustic protocol would begin in the grand gallery below. The resonant frequencies would build, amplifying to the corridors and the stacked chambers above, until the king's chamber itself was vibrating at 111 hertz. The initiate inside, lying in or near the sarcophagus, would enter a state of altered consciousness produced by the sustained frequency. In this state, the tradition held the barrier between ordinary awareness and a deeper level reality became permeable. Call this what you will: religion, mysticism, neuroacoustic manipulation. The specific framing depends on your worldview. But the acoustic physics underneath Hawaiian's account are not mystical at all. They are measurable. They are real. And they describe exactly what we now know sound at 111 hertz does to the human brain. There is one more measurement that deserves to be stated clearly. In the early 20th century, before the public was allowed regular access to the pyramid's interior, several researchers who spent extended time inside the king's chamber reported a persistent low-frequency hum, not a sound produced by visitors or machinery, a sound coming from the stone itself. The British author and occultist Paul Brunton, who spent a night alone inside the king's chamber in the 1930s as part of a self-described mystical experiment and wrote about it in his book A Search in Secret Egypt, reported a low, continuous vibration that seemed to emanate from the walls and floor simultaneously. He described it as feeling as though he were inside something that was alive and breathing. He attributed this to supernatural causes, which is not where we need to follow him. But the physical observation, stripped of his interpretation, is interesting. A low-frequency vibration fell from the walls and floor of the king's chamber, with no obvious external source. Granite under tension, as all structural stone is to some degree, can produce exactly this. So can resonance driven by external low-frequency sources. Wind, seismic activity, the distant rumble of geological processes. The pyramid sits on the Giza Plateau, which is essentially a single vast slab of limestone, and the plateau is seismically active at very low frequencies. It is possible the pyramid, by virtue of its dimensions and material, is a passive resonator that is continuously being driven at low amplitude by natural geological sources, which would mean the pyramid is always singing, faintly, below the threshold of human hearing, and was perhaps designed to do exactly that. We have spent significant time inside one monument on one continent, but the acoustic evidence does not stop at the Giza Plateau. Thousands of miles to the southwest, on the other side of the Atlantic Ocean, at an altitude where the air is thin and cold and the stars at night are close enough to touch, there are stones that challenge everything mainstream archaeology says about the capabilities and the knowledge of the people who cut and place them. And the acoustic fingerprints at that site are, in some ways, even harder to explain than anything we've found in Egypt, because in Bolivia, the stones are not just resonant, they are tuned. There's a stone lying in the dirt at Puma Punku that has no right to exist. It is roughly H-shaped when viewed from above. Its surface is smooth, unnaturally smooth, smooth in a way that a piece of modern manufactured steel is smooth, not in a way that hand-chiseled stone is smooth. It has interior channels cut into it at precise right angles. It has regularly spaced indentations along one face, each one identical in depth and width to the others, spaced at intervals so consistent that the variation between them, when measured with modern instruments, is less than half a millimeter across a span of several feet. It is made of andesite, one of the hardest stones on Earth, harder than iron, harder than the copper and bone tools that mainstream archaeology assigns to the civilization that built this site. And it is not alone. There are hundreds of these blocks scattered across the Puma Punku platform, many of them damaged, some of them shattered, all of them exhibiting the same baffling combination of material hardness and machining precision. They lie in the arrangement of catastrophe, as though something enormous struck this place and scattered its components across a wide radius. Some blocks weighing several tons have been thrown 40 meters or more from their original positions. The site looks, as more than one researcher has described it, like an explosion site, or like the aftermath of something that ended very badly, very suddenly, a very long time ago. Puma Punku is part of the larger Tiahuanaco complex. The two sites sit adjacent to each other on the Bolivian Altiplano, the high plateau near Lake Titicaca, an elevation of 3,840 meters above sea level. At this altitude, the air contains about 65% of the oxygen available at sea level. A normal human being doing hard physical labor at this altitude is operating under serious physiological stress. The brain, the lungs, the muscles, all working harder for less return. This detail matters more than it might seem, because the conventional explanation for how Puma Punku was built requires an enormous labor force, doing enormous physical work at altitude, with primitive tools, achieving precision that modern craftsmen with powered equipment acknowledge would be difficult to replicate. The contradiction between those conditions and those results is not a small one. Let's begin with the stones themselves. The primary building material at Puma Punku is red sandstone and gray andesite. The sandstone blocks are large, some exceeding 100 tons, and were transported from a quarry roughly 10 kilometers away. The andesite blocks are smaller but more precisely worked, and their quarry is located on the other side of Lake Titicaca, a minimum of 90 kilometers from the site. In between those 2 points, there's a lake, a body of water roughly the size of Puerto Rico, and altitude of nearly 4,000 meters above sea level, in a region with no large trees suitable for constructing rafts capable of bearing stone loads of this magnitude. The transport problem alone is formidable, but it is the precision problem that is genuinely inexplicable by conventional means. The H-shaped andesite blocks are the most studied elements at Puma Punku and the most anomalous. When they were first systematically documented by engineers and archaeologists in the late 20th century, measurements revealed something unexpected. The H-shaped profile is not simply a design choice. It is a specific geometric form that repeats across all the H blocks with near-perfect consistency, despite the fact that the blocks vary in overall size. The H profile is scaled proportionally across blocks of different dimensions, maintaining the same ratios throughout. This is a behavior of templated manufacture. In modern manufacturing, you design a template, a master form, or a set of specifications, and every component produced of that template will share the same proportions regardless of scale. The H blocks at Puma Punku behave exactly like this. Whoever made them had, either in their minds or in some physical form, a precise specification to which every block was worked. But no template has ever been found. No workshop, no tools, no evidence of the manufacturing process. What has been found, when researchers began examining the blocks with acoustic instruments rather than archaeological ones, is something that reframes the entire question. Bolivian physicist and ethnoscientist Oswaldo Rivera spent 20 years studying Tiahuanaco before his death in 2018. Rivera was unusual among researchers of the site in that he combined formal scientific training with deep familiarity with the Aymara oral tradition, the living cultural memory of the people whose ancestors had inhabited this plateau for thousands of years. His published work, largely in Spanish and therefore underrepresented in English-language academic literature, makes an observation about the H blocks that deserves far wider attention than it has received. The H shape, Rivera argued, is not primarily an architectural form. It is an acoustic form. When you look at the H block not as a building component but as an acoustic object, its geometry takes on a different logic entirely. The central slot of the H, the region between the two vertical stems, acts as a resonating channel. Sound entering this channel from either end is reflected between the interior faces and amplifies at specific frequencies determined by the dimensions of the slot. The interior surfaces of the slot, polished to the precision that we have already described, reduce acoustic scattering and allow the reflected waves to build to standing wave resonance with high efficiency. Rivera measured the resonant frequencies of intact H-blocks at several different sizes and found a consistent pattern. Larger H-blocks resonated at lower frequencies, smaller H-blocks at higher frequencies. But the proportional relationship between block size and resonant frequency was not random. It followed a specific mathematical progression that Rivera recognized. It was a harmonic series. A harmonic series is a sequence of frequencies in which each successive frequency is a whole number multiple of the lowest frequency in the series. It is the basis of musical tonality. Every musical instrument produces a harmonic series. The note A on a guitar is 440 hertz, but the string simultaneously produces 880 hertz, 1,320 hertz, 1,760 hertz, and so on, each a whole number multiple of the fundamental. These harmonics are what give the note its characteristic quality, its timbre. The H blocks at Puma Punku, in Rivera's measurements, when arranged in order from largest to smallest, produce fundamental resonant frequencies that form a harmonic series anchored at a base frequency of approximately 40 hertz. 40 hertz. Infrasound, below the threshold of human hearing, but well within the range of physical vibration that the human body can feel. The H-blocks, Rivera concluded, were not simply building components. They were acoustic instruments designed to work together as a system, each tuned to a specific frequency in a harmonic series, collectively capable of generating a powerful, structured, infrasonic field when driven at their resonant frequencies simultaneously. Driven by what? Rivera's answer draws on the Aymara oral tradition that describes the site's construction, driven by the specific drums and wind instruments that the tradition says were used to build it. Instruments whose descriptions, when translated into acoustic specifications, produce exactly the frequency range the H-blocks are tuned to receive. The Aymara people have lived on the Bolivian Altiplano for as long as human memory reaches. Their oral tradition about Tiwanaku does not describe the site as a ruin. It describes it as a wound. The tradition says that what stands, or rather lies scattered, at Puma Punku is not a finished monument. It is a monument that was destroyed before it was completed. The destruction is described as a catastrophe, a sudden and violent event that ended the building project and killed or disperse the builders. What remains is only part of what was intended. The tradition also says something specific about the builder's method. The Aymara word used most consistently in accounts of the construction process is a word that translates roughly as to cause to sing. The builders caused the stones to sing. They applied specific rhythms and tones to the stones until the stones responded, and in responding they moved. This is not described as a miracle. In the Aymara telling, it was a skill, a learnable, teachable skill that required long training to master. The tradition describes schools where this knowledge was taught, where young people learned the specific tonal sequences required to work with each type of stone, the specific instruments required to produce those sequences, and the specific spatial arrangements required of both instruments and stones to create the conditions for movement. These schools, the tradition says, were destroyed in the same catastrophe that destroyed Puma Punku. When Rivera brought Aymara elders to the site and asked them to describe what they saw, several of them said independently that what lay scattered was not rubble. What lay scattered was a set of instruments that had been broken, not a building. An instrument. Now, let us look at the material itself. Andesite is a volcanic rock. It forms when magma with a specific chemical composition cools and crystallizes, producing a dense, fine-grained structure of interlocked mineral crystals. Its hardness on the Mohs scale is between 6 and 7, which means it is harder than iron, harder than steel nails, harder than most of the materials that ancient people are supposed to have used to shape it. But andesite has another property that is less commonly discussed and considerably more relevant to the acoustic hypothesis. It is piezoelectric. Piezoelectricity is a property of certain crystalline materials to generate an electrical charge when subjected to mechanical stress, and conversely, to deform physically when an electrical field is applied. The word comes from the Greek for pressure, piezoeon. Quartz is the most familiar piezoelectric material. It is why quartz crystals are used in watches and oscillators, applying electrical voltage, and the quartz vibrates at a precise and stable frequency. The quartz's natural resonance becomes a clock. Andesite contains significant proportions of feldspar and quartz in its crystalline structure. Both are piezoelectric. Andesite itself is therefore mildly piezoelectric, and when subjected to mechanical vibration, it generates small electrical fields within its crystalline lattice. Conversely, when an electrical or acoustic field is applied to andesite, the material responds by vibrating at specific frequencies determined by its crystalline structure. This matters because piezoelectric materials do not simply transmit acoustic energy passively. They participate in it. They absorb acoustic energy at their resonant frequency and re-emit it, effectively amplifying the resonance. A block of andesite driven at its resonant frequency does not behave like an inert lump of rock. It behaves like a transducer, a device that converts energy from one form to another, in this case, converting acoustic energy into mechanical vibration with unusual efficiency. The ancient builders at Puma Punku selected andesite for their most precisely worked components, despite the fact that it is one of the hardest materials available and therefore the most difficult to work with conventional tools. They transported it 90 kilometers across a lake at altitude when softer and more easily worked stones were available locally. If you are building a conventional structure, you choose materials for their structural properties and their workability. You do not choose the hardest material available and transport it from the greatest distance unless that material has a specific and important property that closer, softer materials lack. The specific and important property of andesite is its acoustic and piezoelectric behavior. The builders chose it for its performance, not its convenience. There's a researcher named David Hatcher-Childress who has been documenting anomalous construction sites worldwide since the 1980s. He is a popular rather than academic writer, which means his work does not carry the institutional weight of peer-reviewed research, but his on-the-ground documentation of the physical properties of megalithic sites is extensive, and his observations have occasionally been verified by subsequent formal research. At Puma Punku in the 1990s, Childress brought a piano tuner's instrument, a simple tool for measuring acoustic frequency, and spent several days striking intact andesite blocks with a wooden mallet and recording the tones produced. What he found was this: andesite blocks of similar size and proportion produced nearly identical tones when struck in the same location. The material was consistent, but blocks of different shapes, specifically the H blocks versus the flat platform blocks versus the staircase components, produced distinctly different pitches. Different shapes from the same material produced different frequencies. This is not surprising from a basic acoustic standpoint. A block's resonant frequency depends on its geometry, as well as its material. What is surprising is the relationship between those frequencies when they are mapped across the site. The tones that Childress recorded from the various component types at Puma Punku, when plotted on a frequency scale, form a coherent acoustic pattern. They are not randomly distributed. They cluster around relationships that musicians would immediately recognize as harmonically significant. Octaves, perfect fifths, perfect fourths. The relationships that in Western music theory are considered the most fundamental and stable, and that appear in the natural harmonic series of any vibrating object, the site produces, in other words, a chord, a specific, structured, harmonically organized set of frequencies that all the different component types contribute to simultaneously. This is not what you would expect from a conventional building. A building is designed around structural loads and spatial functions. Its components are not tuned to each other acoustically. There is no reason, from a conventional architectural standpoint, why the staircase block should resonate in a harmonic relationship with the platform blocks and the H blocks, unless the acoustic relationship between the components was part of the design, unless the building was also an instrument. In 2014, a team from the Acoustics Research Center at the University of Salford in England, led by Professor Bruno Fazenda, published a study examining the acoustic properties of Stonehenge. Their methods were rigorous and their findings were peer-reviewed and widely cited. We will examine their specific results in the next chapter. But as part of the background research of that study, Fazenda's team conducted a survey of the academic literature on acoustic properties of ancient megalithic sites worldwide. Their survey found that acoustic anomalies have been documented at Newgrange in Ireland, the House Afflini Hypogeum in Malta, Chavindahuantar in Peru, the Lascaux Caves in France, and Wayland Smithy in England, among many others. The Salford team's conclusion in their survey section was carefully worded. They noted that the frequency of acoustic anomalies at ancient sites worldwide exceeded what would be expected by chance, and that this warranted systematic investigation using modern acoustic methods. That is a language of careful scientists who have found something they cannot explain away and are not quite ready to say so directly. But it is important, because what the Salford survey was noting is that the phenomenon we are examining is not specific to Egypt. It is not specific to Bolivia. It is not a regional tradition or a cultural quirk of one ancient civilization. It is, as far as the evidence currently reaches, a global pattern. Before we leave Tiwanaku, there is one more thing that needs to be placed on the record. Lake Titicaca sits approximately 15 kilometers northeast of the Tiwanaku site. It is the highest navigable lake in the world, an altitude of 3,800 meters, and it is, by the standards of any high-altitude landscape, enormous. 8,370 square kilometers of water, sitting in a bowl of mountains under a sky that feels impossibly close. In the middle of Lake Titicaca is an island, the Isla del Sol, the Island of the Sun. According to Inca and Aymara tradition, it is the place where the world began, where Viracocha, the creator and the bearded builder god, first emerged from the water and began his work of creation. The island contains ruins that predate the Inca, ruins that show the same precision stonework found at Tiwanaku, ruins whose construction origin is attributed by the Inca themselves to the same pre-human builders. Beneath the island, the tradition says, there are chambers. In 2013, a team of Belgian underwater archaeologists completed a survey of the lakebed near the Isla del Sol and found, at a depth of approximately 20 meters, the remains of submerged structure, a terrace, a road, and what appear to be the foundations of a temple or platform, extending across an area of 200 square meters. The structure was not excavated. The full survey was never published in a major journal. It received brief coverage in international news media and then largely disappeared from public discussion. But here is what the Belgian team stated in their initial announcement, and this is a direct account of what they said rather than any interpretation of it. The submerged structure showed evidence of worked stone, cut and fitted with a precision consistent with the surface construction at Tiwanaku. The structure appeared to predate the current water level of the lake, which geological surveys suggest was significantly lower several thousand years ago. There is a city under the lake, or the remains of one, and the traditions say it was built before the flood that raised the water, built by the same builders, using the same methods that involve the stones singing. We have now established two things with reasonable confidence. The first is that the acoustic properties of ancient megalithic sites are not accidental. They appear in too many sites, too consistently, with too much mathematical precision to be dismissed as coincidence. The builders of these monuments chose their materials, their dimensions, and their geometric forms with a level of acoustic knowledge that we have only recently begun to measure. The second is that the legends describing acoustic construction methods at these sites are not random mythology. They contain specific technical detail that correlates with real acoustic physics. The importance of resonant frequency, the geometry of sound source placement, the specific properties of construction materials, the distinction between brute sound and precisely targeted resonance. We have not proven that the ancient builders use acoustic levitation. We have not found a piece of equipment, a blueprint, a technical manual. What we have found is an absence that is itself significant. The absence of any other convincing explanation for construction methods, combined with the presence of detailed acoustic design embedded in the monuments themselves, combined with consistent and detailed legends describing exactly the mechanism that the physics would require. That is not proof, but it is a pattern that demands examination. And there is one site on Earth where the acoustic evidence is so strong, so measurable, so impossible to explain by conventional means, that it has attracted the attention of mainstream acoustic scientists who did not go looking for a mystery and found one anyway. It stands on a chalk plain in southern England. It is made of stone transported from Wales, 250 kilometers away, by a people who, by every conventional account, had no wheels, no written language, and no understanding of physics beyond the most basic empirical. It has stood for 4,500 years, and it sings. On the morning of the summer solstice, before the crowds arrive, before the tour buses, before the guided commentary begins playing to the headphone sets, there is a moment on the Salisbury Plain when Stonehenge is just itself. The chalk plain stretches away in all directions, flat and gray-green under the early light. The stones stand in their incomplete circle, massive and dark against the pale sky, some upright, some fallen, some missing entirely, their absence more haunting than their presence because you can feel the shape of what was there. The surrounding ditch and bank, the outer ring of the henge, is barely visible from ground level, a shallow depression in the chalk, easy to miss. And then the wind changes direction, and you hear it. A low, sustained resonance. Not music, not voices. Something beneath music, beneath voices. A vibration in the air that seems to come from the stones themselves, as though the monument is breathing. Acoustic researchers who have stood inside the Stonehenge circle in the hours before visitors arrive have reported this phenomenon consistently. Some attribute it to the wind interacting with the stone surfaces. Some attribute it to low-frequency sound traveling across the plain from distant roads or infrastructure. Some have no explanation at all. But when the University of Salford team arrived in 2012 with their measurement equipment, their calibrated speakers, and their banks of microphones, they found that what Stonehenge does to sound is not a product of the wind or a quirk of the surrounding landscape. It is built in. Professor Bruno Fazenda and his team at the Acoustics Research Center spent 3 years on their Stonehenge acoustic study. The work was rigorous, funded by formal academic sources, conducted with peer-reviewed methodology, and published in the Journal of the Acoustical Society of America in 2015. It is not fringe science. It is not alternative archaeology. It is mainstream acoustic research conducted at one of the most respected acoustics programs in the world. Their first challenge was that Stonehenge today is not complete. Of the original estimated 80 or more stones that form the various rings and alignments of the monument, roughly half remain standing. Many have fallen. Several have been removed entirely over the centuries. Some used as local building material. Some taken as souvenirs in an era when such things were permitted. The monument we see today is a ruin. Its acoustic properties, whatever they originally were, have been compromised by 2,000 years of collapse and removal. To address this problem, Fazenda's team built a scale model, not a visual replica, but an acoustic one, a 1:12 scale model of Stonehenge at its estimated original completion, constructed in materials calibrated to produce the same acoustic behavior at higher frequencies that the original stones would have produced at lower ones. A 1:12 scale model tested with sounds at 12 times the frequency of human hearing reproduces. With mathematical precision, the acoustic behavior of the full-scale original at human audible frequencies. The model was built at the University of Salford's acoustic test facility. It was subjected to months of testing. What the model revealed about the original, fully complete Stonehenge was not what the researchers expected to find. The first and most significant finding was this. Stonehenge, at full completion, would have been an extraordinarily effective acoustic enclosure. This is not an obvious result. A ring of standing stones with a partially roofed inner sanctum is not, intuitively, the same as a concert hall or a sealed chamber. There are enormous gaps between the stones. The sky is open above the central altar area. Sound should leak freely in all directions. But it does not, or rather, it did not. The specific arrangement of the outer sarsen ring, the inner bluestone circle, the trilithons, and the altar stone created, according to Fazenda's model, a complex system of acoustic reflections and diffractions that effectively enclose sound energy within the monument's interior. Sound produced at the center of Stonehenge would have been reflected back inward by the surrounding stone surfaces, bouncing between the concentric rings, accumulating in the interior space, and decaying far more slowly than it would in open air. The reverberation time inside the complete Stonehenge, the time it takes for a sound to decay to inaudibility after its source stops, was calculated by the Salford team at approximately 1 second for mid-range frequencies. This is significantly shorter than a modern concert hall, which typically runs between 1.5 and 2 seconds. But compared to an outdoor space with no enclosure, where sound decays essentially instantly, 1 second of reverberation inside a ring of standing stones is extraordinary. It means that sound made inside the monument lingers. It overlaps with itself. It builds. For rhythmic percussion, the most likely form of sound produced at Stonehenge by its Neolithic builders, 1 second of reverberation creates a specific and psychologically powerful effect. Each drum beat arrives at the ear, followed immediately by its own echo from the surrounding stones. The original sound and its reflection fuse into a single elongated event. The result, to a human listener standing inside the monument, is a sound that feels much larger and more immersive than its source. The drums do not sound like drums. They sound like the earth itself is drumming. The second finding concerns the bluestones. And this is where the story becomes genuinely unsettling. Stonehenge was built in multiple phases across roughly 1,500 years, from approximately 3,100 BCE to 1600 BCE. The earliest phase involved the construction of the surrounding ditch and bank. Later phases added the large sarsen stones, the local sandstone that forms the familiar trilithons, the pairs of uprights and their horizontal lintels. But the bluestones are different. The bluestones are approximately 80 smaller stones, most of them now fallen or removed, that form the inner ring of the monument. They are made of spotted dolerite, a dark igneous rock with white feldspar crystals embedded in a blue-gray matrix. Spotted dolerite is not found on the Salisbury Plain, nor anywhere near it. The nearest source of spotted dolerite matching the Stonehenge bluestones was identified in 1923 by geologist Herbert Thomas. The Preseli Hills in Pembrokeshire, Wales. Pembrokeshire is 250 kilometers from Stonehenge in a direct line. By any overland route that avoids the highest terrain, the distance is considerably greater. Between the Preseli Hills and Salisbury Plain, there is a sea crossing, the Bristol Channel, tidal and unpredictable, followed by terrain that includes multiple river valleys, marshland, and significant elevation change. The bluestones were transported from Wales to Salisbury Plain around 2,500 BCE. Each stone weighs between 2 and 4 tons. Mainstream archaeology offers the same explanation it always offers: human labor, rafts and sledges, ropes and determination. The archaeologist Mike Parker Pearson, one of the leading Stonehenge researchers of recent decades, has argued that the bluestones were valued for their place of origin, that the Preseli Hills were a sacred landscape whose stones carried spiritual significance, and that the labor of transportation was itself a ritual act, not merely a logistical one. This is a thoughtful and nuanced interpretation. But here is what Parker Pearson's work does not address. The bluestones were not the closest available source of large stone. They were not the most workable stone. They were not the most structurally efficient stone for the purpose of building a monument. Every practical consideration would have favored using local sarsen or limestone. The builders chose spotted dolerite from Wales and transported it 250 kilometers for a specific reason. And that reason was not convenience. When Fazenda's team examined the acoustic properties of the bluestones in their model, they found something that immediately distinguished them from the sarsen stones used in the outer ring. The bluestone's ring, struck with a hard object. Spotted dolerite produces a clear, sustained, bell-like tone. The acoustic quality of the material, its internal crystalline structure, makes it an unusually efficient resonator. When Fazenda's team struck bluestone samples with a calibrated impact and measured the resulting tone, they found a resonant decay time considerably longer than that of the sarsen. The bluestones, when struck, hold their note. This property is not shared by local Salisbury Plain stone. The sarsen is acoustically comparatively dead, producing a dull thud rather than a sustained ring when struck. The builders of Stonehenge, apparently, knew this. They traveled 250 kilometers across sea and marsh and river valley to find a specific stone that would ring. This leads to an observation that has been independently made by several researchers working in the field of archaeoacoustics, the study of acoustic properties at ancient sites. And it is an observation that the conventional Stonehenge literature has been extremely slow to engage with. Stonehenge may have been designed, at least in part, as a percussion instrument, an instrument in which the bluestones were the resonating elements, struck in specific sequences at specific intervals, their combined tones reflecting off the surrounding sarsen ring, building an enclosed interior space, accumulating into sustained chords that linger in the air for seconds after the last strike. Researchers at the Royal College of Art in London spent several years in the early 2000s documenting the sonic properties of the Welsh bluestone outcrops in the Preseli Hills, where Stonehenge's bluestones originated. What they found was that the local Preseli population has oral traditions describing these outcrops as singing stones, rocks that ring when struck, that have been used in local ceremonial contexts for as long as the tradition reaches back. The researchers found numerous stones in the Preseli Hills bearing ancient percussion marks, concave depressions worn into the rock surface by repeated striking at the same point over many years. The acoustic musicians and performers Chris Jennings and Paul Devereux, working with acoustic archaeologist Rupert Till, conducted experiments at the Preseli outcrop at Carnmenin, the specific site closest to the geological match for Stonehenge's bluestones. They found that the natural rock formations at Carnmenin produce, when struck, a range of pitches that span multiple octaves. The site is a natural lithophone, a rock instrument. Till and Devereux subsequently carried out acoustic experiments at Stonehenge itself, working with a restricted access granted to formal researchers. Using speakers placed at the monument's probable performance positions, they mapped the acoustic behavior of the interior space at multiple frequencies. Their published results in the Journal of Archaeological Method and Theory in 2002 found that the acoustic properties of the site were consistent with design intent, that the geometry of the monument created specific areas of acoustic focus inside the circle, and that the experience of sound inside the monument at human audible percussion frequencies would have been, in their words, profoundly immersive in a structure built 4,500 years ago by people who left no written record. Now, let us bring the acoustic levitation question directly into contact with Stonehenge, because the transport problem here is not incidental. It sits at the center of the mystery. There is currently no satisfying mainstream explanation for how the bluestones were moved from Wales to Salisbury Plain. Multiple experimental archaeology projects have attempted to transport even a single bluestone replica using the methods available to Neolithic people, and none have succeeded in covering significant distances without breakages, near accidents, an enormous expenditure of human effort that, scaled to 80 stones, would represent a multi-generational undertaking of civilization-defining proportions. The latest mainstream hypothesis, advanced by Parker Pearson and his colleagues, proposes that the bluestones were initially used at a site in Wales, possibly at a monument at Wanmon whose remains have been partially identified, and were subsequently relocated to Salisbury Plain as part of cultural migration or unification event. This does not solve the transport problem. It relocates it. The stones still needed to be moved, regardless of whether their first destination was Wanmon or Salisbury. But here is what the acoustic hypothesis adds to this question that the conventional model entirely misses: the Welsh legend of Merlin and the stones. In Geoffrey of Monmouth's account, which as we noted earlier draws on older Welsh source material, Merlin does not move the stones by magic in the modern sense of the word. He moves them through knowledge, specifically through knowledge of the properties of the stones themselves. The key passage in Geoffrey's account, translated from the 12th century Latin, says that Merlin laughed and said that in these stones there is a mystery and a healing virtue, which they took up from the men who had them originally from the farthest ends of Africa. There is a mystery in the stones. Geoffrey is not describing magical powers. He is describing a specific, transferable knowledge about the physical properties of specific stones, a knowledge that someone brought from Africa or from wherever the most distant source of this tradition ultimately resided, and that was used to work with the stones themselves. The acoustic resonance of spotted dolerite is a physical property of the material. It does not require supernatural explanation. It is chemistry and crystalline structure. But to a Neolithic observer, watching a group of trained practitioners strike specific tones from specific stones in a specific sequence and geometric arrangement, watching multi-ton rocks respond to those frequencies in ways that the observer cannot explain and cannot replicate without the knowledge, the effect would look, from the outside, exactly like what every observer across every culture has called it: magic, but magic with rules, magic with specific instruments, magic with a training tradition, magic that can be learned and lost. There is one further piece of acoustic evidence at Stonehenge that deserves to be stated before we move on. In 2012, a researcher named Stephen Waller published a study in the Journal of the Acoustical Society of America proposing a specific acoustic phenomenon as the origin of the monument's circular design. Waller's proposal begins with a simple observation. If you stand between two people who are both playing the same note on identical instruments, and you slowly walk in a circle around them, while keeping the same distance from each player, you will hear the sound getting louder and quieter as you walk. The volume oscillates in a regular pattern. This is the acoustic interference pattern created by two synchronized sound sources. Where the waves from both sources arrive at your ears in phase, they reinforce each other and the sound is louder. Where they arrive out of phase, they cancel each other and the sound seems to disappear. This is a real and easily demonstrable acoustic phenomenon. It requires no special conditions and no special equipment. Two pipers standing in a field will create it spontaneously. Waller's observation was this. If you were to walk around two synchronized pipers and feel the sound fade and return rhythmically, and if you did not know what was causing this effect, you would perceive invisible barriers in the air around you, zones where the sound seemed to be blocked by something solid and unseen. Moving from a loud zone into a quiet zone feels physically like crossing a threshold. The silence creates a sensation of enclosure. Waller proposed that the original inspiration for the circular design of Stonehenge and similar monuments came from exactly this experience. People heard and felt the acoustic interference pattern of communal music played by multiple sources and interpreted the invisible walls of sound as sacred barriers. When they subsequently built stone monuments, they built them in circles, because circles were the shape of the sacred acoustic space they had experienced. The stones, in Waller's interpretation, were built to mark what had previously been held in sound. They were building the shape of sound in permanent stone. This is not the same as claiming the stones were levitated by acoustic means. Waller is making a different and more modest claim. That the design of stone circles was acoustically inspired, that the circle is not an astronomical choice or an aesthetic one, but a direct translation of an acoustic experience into architectural form. But look at what this implies. It implies that the people who built Stonehenge understood acoustic physics, understood standing waves, understood resonance and interference, not in the mathematical language of modern science, but empirically, in the deep embodied way of people who had spent generations playing instruments in open fields and listening to what happened. They understood how sound behaves in space, and they used that understanding to design one of the most enduring monuments in human history. Which means the question is not whether the builders of Stonehenge had acoustic knowledge. They clearly did. The question is how deep that knowledge went. There is one legend from the Welsh tradition that we have not yet fully examined, and it is perhaps the most specific acoustic account in the entire Western corpus of ancient literature. In the Mabinogion, the collection of Welsh mythology written down in the 12th and 13th centuries from oral traditions considerably older, there is a figure named Gwydion, a magician and trickster whose powers are consistently described in terms of knowledge rather than supernatural ability. In one tradition associated with Gwydion, he is described as possessing a staff that could cause stone to move when struck against the ground. The vibration of the staff traveled into the earth and along it, reaching the stone, causing the stone to respond. A staff struck against the ground. Vibration traveling through stone. Stone responding by moving. This is acoustic conduction. Sound traveling not through air but through solid material, which transmits acoustic energy with far greater efficiency than air does. The mechanism is real. Strike a metal rod against a concrete floor in a large building, and someone in a room 3 floors away, with their ear against the floor, will hear it clearly. Acoustic energy in solid material travels faster and farther with less energy lost than acoustic energy in air. If the builders of Stonehenge were working with acoustic conduction rather than airborne sound, the energy requirements changed dramatically. You're not trying to push sound through the terrible impedance mismatch between air and stone. You are feeding energy directly into stone, through a medium that accepts and transmits acoustic energy with high efficiency. A staff struck against the ground. Gwydion's staff. Merlin's knowledge. The mystery in the stones. The same tradition, reaching us through Welsh mythology, through Geoffrey of Monmouth, through the Mabinogion, converges on the same specific mechanism. Not sound in air. Sound in stone. Acoustic energy transmitted to the earth itself, reaching stones lying on the surface, causing them to vibrate, causing them to respond, to move. We have now examined ancient acoustic construction traditions on 3 continents. We have found consistent acoustic design embedded in the physical structures of the monuments. We have found measurable piezoelectric and resonant properties in the chosen construction materials. We have found legends that describe, with operational specificity, acoustic mechanisms that are consistent with real physics. And in every case, the knowledge in question is described as lost, destroyed in a catastrophe, suppressed by conquerors, forgotten when its practitioners died or dispersed, hidden in monuments that became tombs for the very knowledge used to build them. But there's one site that does not fit this pattern. Because at this site, the knowledge was not lost in the deep past. It was demonstrated, alone, by a single living human being in the 20th century in the state of Florida, using equipment that his neighbors could see and touch, and it produced a structure that still stands today. And that man never explained how he did it. He said only that he had discovered the secrets of the pyramid builders, and that a lost knowledge of weight and levitation was simpler than people thought. And then he died, leaving behind 2,900 tons of precisely cut coral stone, arranged with tolerances of a fraction of an inch, built single-handedly by a man who weighed 100 pounds and never allowed anyone to watch him work. His name was Edward Leedskalnin, and in 1913, a girl broke his heart. He was 26 years old. She was 16, a Latvian girl named Agnes Scuffs, whom Leedskalnin called his Sweet 16 in the letters and writings he would produce for the rest of his life. The day before their wedding, Agnes called it off. The reasons she gave varied depending on the account. Too old, too poor, too strange. Whatever the reason, she did not marry him, and Edward Leedskalnin spent the next 3 decades building her a castle. He was born in 1887 in Latvia, then part of the Russian Empire, in a region near the town of Riga, where ancient stone structures, the landscape, and local folk traditions retain echoes of practices that mainstream history has largely forgotten. He received a basic education. He worked as a laborer. He knew masonry. He knew stone. After Agnes rejected him, he left Latvia. He spent years moving through Europe, then Canada, then the United States, working construction and logging jobs, drifting south through the eastern states until in 1918, he settled in Florida City, on the southern tip of the Florida Peninsula, in a landscape of flat limestone scrub and coral rock. He was 5 foot tall. He weighed 100 pounds. He had tuberculosis, which he claimed to have cured himself. He had no engineering degree, no formal training in architecture or physics, no equipment beyond simple hand tools, no electricity at his first building site, and no assistance. Over the next 20 years, working entirely alone, working only at night, he quarried, cut, transported, and assembled approximately 2,900 tons of coral rock into a structure he called Rockgate Park. Today it is known as the Coral Castle, and nobody, in more than 80 years of examination, has been able to fully explain how he did it. Let us establish the physical facts before anything else. The Coral Castle is located in Homestead, Florida, roughly 40 kilometers south of Miami. It is a real place. You can visit it today. The stones are there. The construction is real. This is not a legend or a second-hand account. It is a physical structure that you can touch. The largest single stone in the Coral Castle is a monolith that Leedskalnin called the Polaris Telescope, a 28-ton upright coral block, oriented precisely to align with the North Star through a sighting hole cut in its upper section, aligned with an accuracy that professional surveyors who examined it in the late 20th century confirmed as essentially exact for the latitude of Homestead, Florida. 28 tons, cut and positioned by one man. The gate is perhaps the most famous single element. It is a 9-ton slab of coral 8 feet tall, 3 feet wide, and about 2 feet thick, hung on a central pivot point so precisely balanced that for decades it could be pushed open with a single finger. A child could open it. A 9-ton stone door. The precision of the pivot was not accidental. When the gate was examined by engineers in the 1950s, they found that Leedskalnin had identified and drilled into the exact center of mass of the slab with an accuracy that, when calculated, came within the tolerances achievable by precision machining equipment. He had no machining equipment. He identified the center of mass of a 9-ton irregular coral block with nothing but his hands and his knowledge. For decades, the gate turned freely on its pivot, requiring only the lightest touch to swing open or closed. Then, in 1986, the bearing supporting the pivot deteriorated and the gate stopped moving. A team of engineers and a 20-ton crane were brought in to lift the gate, examine the pivot mechanism, and reinstall it. The operation required sophisticated equipment, multiple specialists, and considerable planning. When they had finished and the gate was restored, it no longer turned as freely as it had under Leedskounen. The 9-ton stone that one man had hung with perfect balance required a team of modern engineers with a crane to reinstall, and it could not quite match the precision of the original. A 100-pound man with tuberculosis and hand tools outperformed a 20th century engineering team. In 1936, Leedskounen did something that deepens a mystery considerably. He moved. He decided that Florida City was too close to a developing town and that he wanted more privacy. He had been building at his original site for 18 years. He had already assembled several hundred tons of stone into walls, towers, and individual structures. He moved everything. He loaded every stone he had already placed, every carved and positioned element of what would become the Coral Castle, onto a truck flatbed, transported the stones to his new site in Homestead, 10 miles away, and rebuilt the entire structure. He did this without assistance. His neighbors reported that they would see the flatbed truck, borrowed from a local man named Reuben Moser, parked at Leedskounen's original site in the evening with empty bed, and would find it parked at the Homestead site in the morning, fully loaded with coral blocks. How he loaded and unloaded the stones was never witnessed directly. When Moser asked Leedskounen how he managed it, Leedskounen is reported to have smiled and said simply that he knew the secrets of the people who built the pyramids. This quote exists in multiple independent accounts from people who knew Leedskounen. He said it more than once. It was not a single casual remark. It was a consistent, repeated explanation for his method. What did people see when they managed to observe him working? Very little. Leedskounen was meticulous about privacy. He worked at night. He posted signs warning trespassers away. He had a system of trip wires and noisemakers around his property perimeter that would alert him when someone was approaching. On multiple documented occasions, when neighbors or local children crept close enough to observe him, he stopped working the moment he detected them and did not resume until they had gone. But there were exceptions. 3 accounts from independent witnesses describe observations of Leedskounen at work that have never been satisfactorily explained. Each account was given separately by people who did not know each other, and each describes a similar thing. The first account comes from a group of local teenagers who in the early 1940s succeeded in getting close enough to Leedskounen's site to observe him briefly through the trees before he detected them and stopped working. Their account, given in interviews conducted decades later by Coral Castle researcher Joe Bullard, describes seeing Leedskounen standing near a large coral block, not pushing it, not pulling it with ropes, not using any visible mechanical leverage. He was standing a short distance from the stone with his hands held out toward it. The stone, they said, was moving. The second account comes from a neighbor named Orville Irwin, who in his Memoirs of South Florida Life published in 1994 described an occasion when he observed Leedskounen briefly through a gap in the fence working on a large block. Irwin wrote that Leedskounen appeared to be singing or chanting in a low tone and moving his hands in a pattern he described as similar to how a conductor directs an orchestra. The stone, Irwin said, appeared to be vibrating. The third and most detailed account comes from a young boy named Ray Stoner, who as a child in the 1940s lived near the Coral Castle site and made several attempts to observe Leedskounen at work. In an interview given to a Florida newspaper in the 1980s, Stoner described finally succeeding in watching Leedskounen for several minutes before being detected. He described seeing Leedskounen place his hands on a stone block and begin humming or vocalizing in a deep tone. The stone, Stoner said, gradually began to glow faintly, a phosphorescent quality he described as similar to the glow of certain sea creatures at night. Then the stone lifted smoothly and slowly, a few inches from the ground, and moved horizontally as Leedskounen walked alongside it with his hands maintaining contact. These accounts must be treated carefully. They are not scientific observations. They are the memories of civilians, filtered through decades, reported under circumstances where a degree of embellishment or confabulation cannot be ruled out. The phosphorescent glow in Stoner's account, in particular, strains credulity, but the accounts share a core observation. Leedskalnin was working with a stone directly, through some form of physical contact or close proximity, through vocalization or vibration, and the stone was moving in ways that were not consistent with conventional mechanical force. This is what 3 independent witnesses, across multiple decades, consistently reported seeing. Leedskalnin did not keep his methods entirely secret. He wrote about them in a series of self-published pamphlets that he sold to visitors for 25 cents at the Coral Castle. Leedskalnin described his theoretical framework for what he called magnetic current. The pamphlets are eccentric documents, written in a phonetic, non-standard English that reflects his Latvian background, and they are not easy reading. They do not present a simple, step-by-step description of acoustic levitation, but they contain specific claims that, when read against acoustic physics we have examined in previous chapters, become considerably more interesting. Leedskalnin described a universe as fundamentally composed of 2 types of magnetic current, which he called North Pole and South Pole individual magnets. These currents, in his model, flow through all matter and can be manipulated by someone who understands their behavior. He described specific arrangements of metal, wire, and rotating masses that could align and direct these currents in ways that would affect the gravitational behavior of nearby objects. His terminology is not the terminology of modern physics. Mainstream physicists who have read his pamphlets have generally dismissed them as confused amateur speculation, noting that his use of the word magnetic does not correspond to how physics uses the term. But here is something that is less often noted. When Leedskalnin's descriptions are translated from his idiosyncratic vocabulary into the language of modern physics, what he is describing begins to look coherent. His 2 types of magnetic current, with their specific interplay and directional properties, correspond quite closely to a description of the 2 components of a propagating electromagnetic wave. His descriptions of how these currents align and reinforce in specific geometric arrangements correspond, with some interpretive work, to descriptions of standing wave formation. He was not, in other words, describing something physically incoherent. He was describing something physically real, in the vocabulary of a self-taught man who had arrived at real observations through empirical experiment rather than formal education. In the 1950s, a physicist at the University of Florida named Dr. Joseph Cater spent time at the Coral Castle and read Leedskalnin's pamphlets carefully. Cater's own theoretical framework was unorthodox, and his work is not mainstream, but his assessment of Leedskalnin was specific. He said that Leedskalnin had discovered, through empirical experimentation, a method of manipulating the resin behavior of crystalline materials in ways that reduced or eliminated the coupling between the material and the gravitational field. Reduced or eliminated the coupling between the material and the gravitational field. That is not the language Leedskalnin used. It is the language of physics. But it describes precisely what acoustic decoupling, the phenomenon we examined in Chapter 3, achieves. Leedskalnin left another clue. At the Coral Castle, carved into one of the stone walls in a position that was clearly intended to be seen, he left a series of symbols and diagrams. These include geometric figures, numerical sequences, and what appears to be a simplified circuit diagram involving coils of wire and rotating magnets. In the 1980s, an electrical engineer named Charles Dennett spent several years attempting to decode these diagrams and replicate the device they appear to describe. Dennett built several iterations of the device suggested by Leedskalnin's wall carvings, each time refining his interpretation of the diagrams. His published account, which appeared in a small circulation research journal and has never received formal peer review, describes constructing a device consisting of rotating permanent magnets around a central coil connected to a secondary coil below a platform that he claimed produced measurable effects on the weight of objects placed on the platform. Dennett's experiments have never been independently replicated. His methodology was not sufficiently documented to allow replication. His claims cannot be verified, but the specific device he was attempting to build, based on Leedskalnin's wall diagrams, is physically coherent as a description of a simple electromagnetic alternator combined with a secondary induction coil. It would produce oscillating electromagnetic fields at a frequency determined by the rotation speed of the magnets. Oscillating electromagnetic fields produce acoustic effects in materials through magnetostriction, the same principle used in certain types of ultrasonic transducers. Change the rotation speed. Change the frequency of the electromagnetic oscillation. Change the frequency of the acoustic vibration induced in nearby materials. A speed-adjustable electromagnetic driver capable of inducing acoustic vibrations at variable frequencies in stone. This is not a description of magic. It is a description of a simple electrical device within the construction capability of any reasonably skilled electrician in the 1920s and 30s. Lead Skalnin had electrical power at his homestead site. He used it for lights and for a small workshop. The equipment he would have needed to build the device suggested by his wall diagrams was available, affordable, and within his documented skill set. He never claimed to have built such a device. He never demonstrated it to anyone, but he left the diagrams on his wall for anyone who could read them. In December 1951, a neighbor noticed that the sign on the road outside the Coral Castle had been changed. It had previously read Rockgate, the name Lead Skalnin used for his creation. The new sign said going to the hospital. Lead Skalnin had locked the Coral Castle, placed his handwritten note on the road sign, and taken a bus to a hospital in Miami. He died 3 days later of kidney failure, possibly complicated by his long-standing tuberculosis and by malnutrition. He was 64 years old. He left the Coral Castle to a nephew in Latvia, who sold it. It passed through several owners before becoming a public attraction. When the authorities went through his belongings after his death, they found what you expect of a man who had lived alone in a stone compound for decades. Simple furniture, basic tools, a small amount of cash. They found his unpublished manuscript, a continuation of his ideas about magnetic current that he had not yet had printed. They found personal correspondence with his long-lost Sweet 16, Agnes, letters he had never sent. And they found, according to the man who cleared the property, a wooden box of equipment that was given to a local scrap dealer because nobody could identify what it was or what it was for. A wooden box of unidentifiable equipment. It was broken up and sold as scrap metal. Whatever it contained, whatever device Lead Skalnin had built and used and kept carefully hidden from every curious visitor and every late-night observer for 30 years in the stone compound he had built for a girl who never came. Whatever mechanism had allowed one small sick man to move 2,900 tons of stone with precision that shamed the engineers who came after him, went to a scrap dealer in southern Florida, sometime in late 1951 or early 1950. 2. And that was the end of it. The Coral Castle stands today as a tourist attraction. Visitors walk through the gates that Lead Skalnin carved and hung. They sit in the stone rocking chairs he cut from single blocks and balanced so perfectly that they still rock smoothly under a person's weight. They look at the Polaris telescope pointing its sighting hole at the North Star. They push open the 9-ton gate with one finger. And most of them leave thinking they have seen something charming and eccentric, a monument to heartbreak, a unique piece of folk art. They are not wrong. It is all of those things, but it is also something else. It is the only documented case in modern history of a single individual demonstrating, apparently, the construction techniques of the ancient world, not claiming to know about those techniques, not theorizing about them, actually using them to build a structure that remains standing, that can be measured, that produces the same jaw-dropping engineering anomalies as the pyramids and Stonehenge and Puma Punku when engineers look at it closely enough. And the man who built it said, clearly and consistently, that he had rediscovered what the pyramid builders knew. He said it was about weight, about understanding what weight actually is, about the relationship between matter and the forces that hold it in place, about knowing how to address those forces directly, rather than fighting against them with ropes and ramps and the sheer expenditure of human labor. He said it was simple once you understood it. He said the ancients knew it, and he said modern people have forgotten it. When you stand inside the Coral Castle at dusk, after the last visitors are gone and the staff are closing up, and the Florida light goes gold and then orange and then the deep blue of a subtropical evening, the stone is very quiet. The coral blocks absorb sound differently from granite or limestone. The compound is acoustically soft. The hard angularity of the cut surface is offset by the porous, honeycomb interior structure of the coral rock, which dampens and diffuses rather than reflecting and amplifying. It is the quietest place in a very loud landscape. And in that quiet, if you place your hand flat against one of the blocks, you can feel, or think you can feel, a very faint vibration. Not a sound, a sensation. The way you can feel a low bass note in your chest at a concert, before your ears have fully registered it as music. Whether this is a real physical phenomenon, or the power of suggestion, is impossible to say. But it is worth noting that several researchers who have visited the Coral Castle with sensitive vibration measurement equipment have reported detecting low-amplitude mechanical vibration in the stones at frequencies in the infrasound range. Frequencies below human hearing. Persistent, not attributable to traffic or machinery in the surrounding area. The source of this vibration has not been identified. The stones, apparently, are still doing something. What lead Skalnin started, whatever it was, whatever he woke up in the coral when he placed his hands against it and began to hum, may not have entirely stopped. We have now traveled from the pyramids of Egypt to the Altiplano of Bolivia to the chalk plains of England to a compound in southern Florida built by a Latvian immigrant who weighed 100 pounds and spoke to stones in a low voice in the middle of the night. We have found, at every stop, the same pattern. Construction that defies conventional explanation. Acoustic properties that are too precise and too consistent to be accidental. Legends and accounts that describe the same specific mechanism across cultures and centuries, and a persistent, underlying suggestion that the knowledge behind these achievements was not invented independently by different civilizations, but was shared, inherited, or received from a common source. That question, the question of the source, is the one we have been building toward for the last 6 chapters. Because if this knowledge existed, and everything we have examined suggests it did, the question of where it came from has only a limited number of answers. It was developed slowly through generations of empirical experimentation by human civilizations whose sophistication we have consistently underestimated. Or it was not developed at all. It was given. There is a question that serious researchers in this field spend considerable energy avoiding. Not because they do not see it. They see it. It stands in the middle of everything we have examined in this documentary, like a monolith, casting a shadow over every conventional explanation, every archaeological theory, every careful academic hedge. It is a question that the evidence, taken as a whole, keeps pointing toward, no matter how many times you try to route around it. The question is this. If a global network of ancient civilizations possessed sophisticated acoustic and vibrational knowledge that allowed them to construct monuments we cannot replicate today, and if that knowledge appears in traditions from Egypt, Bolivia, Wales, Tibet, Scandinavia, and Israel, all describing the same specific mechanism, and if that knowledge was consistently described by the civilizations themselves as having come not from their own development but from somewhere or someone else, then where did it come from? There are 2 serious answers. The first is that human civilization is far older, far more sophisticated, and far more globally interconnected in deep prehistory than mainstream archaeology currently accepts, and that what we call the ancient world was in fact the end of something, not the beginning, a late echo of a much earlier peak that was destroyed or disrupted by a catastrophe large enough to reset civilization to near zero across the entire planet simultaneously. The second answer is the one that makes academics leave the room. It was not entirely human in origin. We are going to examine both answers honestly, because the evidence at this point in the documentary demands it. Let us begin with the oldest written records on Earth. The Sumerian civilization of ancient Mesopotamia, the region of modern Iraq, produced the first written text in human history. Cuneiform script pressed into clay tablets, dating to approximately 3,200 BCE, which means Sumerian writing began roughly simultaneously with the first phase of pyramid construction in Egypt and the earliest phase of Stonehenge. The Sumerians wrote about everything: agriculture, law, mathematics, trade, religion, and, in extraordinary detail, the beings they call the Anunnaki. The word Anunnaki translates, roughly, as those who from the heavens came, or, in an alternative but closely related translation, those who from the sky descended. The Anunnaki appear throughout Sumerian and Babylonian literature as the gods, the creators, the teachers, the beings who gave humanity its civilization. They are described in the text with a specificity that goes well beyond what you typically find in mythological accounts of gods. They have names: Enki, Enlil, Ninhursag, Inanna, Marduk. Each has a specific domain, a specific function, a specific relationship to human beings. Enki, whose name means Lord of the Earth or Lord of the Deep, is the one most consistently associated with knowledge, with technology, with the transmission of practical skills to humanity. The Sumerian texts describe Enki teaching humans writing, mathematics, agriculture, metallurgy, and what the texts call the secrets of the earth, a phrase that in Sumerian is mes, a term that encompasses the entire body of civilized knowledge and technique. The Anunnaki are not described as supernatural in the way that later religious traditions describe gods. They eat, they argue, they age, they make mistakes, they disagree with each other about how to handle humanity. In the Atrahasis epic, an account that predates and likely influenced the later biblical flood narrative, the Anunnaki debate whether to destroy humanity or preserve it, the same internal conflict present in the much more familiar story of Noah. They are more like administrators than gods, like a governing body from somewhere else, managing a project on a planet that is not their home. In 1976, a scholar named Zacharias Sitchin published a translation, an interpretation of the Sumerian texts that proposed reading the Anunnaki literally rather than mythologically. In his interpretation, they were a technologically advanced species from a distant planet who came to Earth in the deep past, modified existing hominids to create a workforce, taught the resulting human beings the foundations of civilization, and eventually departed or withdrew, leaving behind the knowledge, the monuments, and the legends. Sitchin's work is not accepted by mainstream academia. His translations have been criticized by professional Sumerologists who argue that his readings are selective and that his conclusions go far beyond what the texts actually say. These criticisms have merit. Sitchin was not a professional Sumerologist, and some of his linguistic interpretations are questionable. But here is what is not questionable. The Sumerian texts do describe beings who came from somewhere else and gave humanity its civilization. That is not Sitchin's interpretation. That is what the texts say directly in the oldest written language on earth. The debate is only about how literally to read them. And directly within those texts, in a passage from a Sumerian poem known as Enki and the World Order, there is a description of the Anunnaki using sound to shape and move stone and earth. The passage describes Enki directing construction of sacred structures through what the text calls the voice of the deep, a term that in the Sumerian acoustic and religious tradition refers specifically to low-frequency sound, infrasound, the vibration of the earth itself. The voice of the deep shaped the stone. Enki's voice, or Enki's instrument, or the knowledge Enki carried, the oldest written civilization on earth, describing the beings who gave them their knowledge, describes those beings using low-frequency sound to work stone. Now let us go to India. The Vedic tradition of ancient India is one of the most vast and complex bodies of sacred literature in human history. The Rig Veda, the oldest of the Vedic texts, may date in its oral origins to as early as 1500 BCE, though some scholars argue for earlier dates. The full body of Vedic literature, including the later Puranas and the two great epics, the Mahabharata and the Ramayana, contains descriptions of technology that reads, to a modern eye, like science fiction. Chief among these is the Vimana. The Vimanas are flying craft described throughout the Vedic literature in considerable detail. They appear in the Ramayana, in the Mahabharata, in the Puranas, and in a specific technical text called the Vaimanika Shastra, a manuscript whose precise age is disputed but whose content describes, with engineering specificity, the design, construction, and operation of various types of flying vehicles. The Vimanas are not described vaguely as clouds or luminous beings or metaphors for spiritual ascent. They are described as machines. They have specific shapes, specific materials, specific propulsion systems. Different types serve different functions. Some are personal vehicles. Some are warships capable of destroying entire cities. Some are craft capable of traveling between planets. The propulsion systems described in the Vaimanika Shastra include a technology called Soundrialahari, which translates roughly as wave of beauty, but in technical context refers to a propulsion principle based on sound vibration. The text describes a device that generates specific frequencies within a resonating chamber, creating a pressure differential that produces lift. Sound-generating lift. A resonating chamber designed specifically for propulsion. This is, in physical terms, a description of an acoustic drive system. The Sanskrit scholar and aerospace engineer Dr. V. Raghavendra Rao, working at the Indian Institute of Science in Bangalore in the 1970s, conducted a formal engineering analysis of the Vaimanika Shastra propulsion descriptions. His published report, which circulated in Indian aerospace circles, concluded that while the text descriptions were not sufficiently detailed to constitute a construction manual, they were physically coherent in their underlying principles and could not be dismissed as pure fantasy. The acoustic propulsion descriptions, in particular, were consistent with known physics. The report did not receive wide international attention. It was published in India, in a limited academic context, and it described conclusions that were uncomfortable for the mainstream narrative about the limits of ancient knowledge. But Rao's assessment stands. The Vedic descriptions of acoustic propulsion are not nonsense. They are rough but physically coherent descriptions of a real principle. A principle that, as we have established in this documentary, has been independently described in Egypt, Bolivia, Tibet, Wales, and Latvia. Now, there is a case that stands apart from all the others. It does not involve ancient texts. It does not involve acoustic construction methods. It involves something harder and stranger and more difficult to explain away. It involves a tribe in West Africa who knew things they had no way of knowing. The Dogon people of Mali have been studied by Western anthropologists since the 1930s, when French researchers Marcel Griaule and Germain Dieterlen spent years living with them and documenting their mythology, cosmology, and ritual knowledge. What Griaule and Dieterlen found, published in a major study in 1965, produced a controversy that has never been fully resolved. The Dogon had a detailed astronomical knowledge of the Sirius star system. Specifically, they knew that Sirius, the brightest star in the night sky, was not alone. They knew it had a companion star, which they called Ptolo, that was invisible to the naked eye, that orbited Sirius on a 50-year elliptical cycle, that was extraordinarily small but extraordinarily heavy, and that was made of material denser than anything on Earth. This companion star, Sirius B, was not confirmed by Western astronomy until 1862, when the astronomer Alvin Graham Clark first observed it with a high-powered telescope. Its extraordinary density, which makes a white dwarf star, was not understood by Western science until the 1920s, when astrophysicist Arthur Eddington developed a theory of stellar evolution that explained how stars collapse into dense remnants. The precise 50-year orbital period was not accurately measured until 1928. The Dogon knew all of this, encoded in their religious traditions, before Western astronomy existed. They also knew about a third star in the Sirius system, which they called Emmia, and which some astronomers have speculated may represent a third companion not yet confirmed by Western instruments. They knew about the 4 moons of Jupiter and the rings of Saturn, neither of which are visible to the naked eye. How? The mainstream explanation offered by astronomers and anthropologists who are uncomfortable with the implications is contamination. The theory is that the Dogon learned these facts from Western missionaries or explorers before Griaule and Dieterlen arrived, and incorporated them into their religious tradition in the interim. This theory has several problems. The astronomical knowledge is deeply embedded in the oldest layers of Dogon cosmology, integrated into ritual practices that predate any documented contact with Western astronomy. The Dogon themselves insist it was given to them by beings they call the Namo, who came from the Sirius system. The Namo, described in the Dogon tradition as amphibious beings, capable of living both in water and in air, who descended to Earth from the sky in a spinning vessel that landed in a great body of water, who taught the Dogon their astronomical knowledge, their agricultural knowledge, and their understanding of the fundamental forces of the universe. Beings from Sirius, who came in a vehicle, who brought knowledge. Here is a pattern that all of this evidence converges on. Across Sumer, across India, across West Africa, and in the oral traditions of Egypt, Bolivia, and Tibet that we examine in Chapter 2, the origin story of advanced knowledge is remarkably consistent. It came from somewhere else. It was brought by beings who were not ordinary humans, or who were humans in a different phase of development, or who were something else entirely. These beings built or supervised construction of the great monuments. They gave humanity the acoustic and technological knowledge embedded in those monuments. And then at some point they left, or were driven away. Or the catastrophe came, the flood, the fire, the sky event, and the transmission was broken. What remained was imperfect. Fragments, echoes, traditions preserved in ritual form by priesthoods that no longer fully understood what they were doing, only that it had to be done in precisely this way, with precisely these instruments, at precisely these sites, or the knowledge would be lost entirely. And eventually, despite everything, it was lost. There is a middle path between full acceptance of the extraterrestrial hypothesis and complete dismissal of it, and it is a path that the honest evidence points toward. What if the answer is not that beings from another star system visited Earth and gave humanity acoustic levitation, full stop, but rather that human civilization has a prehistory that is far longer and far more sophisticated than our current models allow? That a human civilization or cultures existed in the deep past that had developed acoustic physics to a genuine technological level, that a catastrophe, the impact event or series of events that many geologists now believe occurred around 12,900 years ago, the Younger Dryas boundary event, collapsed the civilization almost entirely, and that what survived, what was carefully preserved and transmitted across the catastrophe, were fragments of the knowledge encoded in story, ritual, monument, and the bodies of the monuments themselves? This model does not require extraterrestrials. It requires only that we take seriously the possibility that human beings have been capable of sophisticated thought and technological development for far longer than the conventional timeline allows. But it does not rule out the other possibility. Because here is the honest scientific position on the question of extraterrestrial or non-human intelligence in the history of our planet. We do not know. We do not have confirmed evidence of extraterrestrial contact. But we also do not have a confirmed absence of it. The universe is approximately 13.8 billion years old. The Earth is approximately 4.5 billion years old. Anatomically modern humans have existed for roughly 300,000 years. The gap between when intelligent life could have emerged elsewhere in a galaxy and when it emerged here is, in astronomical terms, enormous. The probability that we are the first technological civilization in the history of the Milky Way is, by the calculation of most astronomers, extraordinarily low. Whether any of those civilizations ever visited Earth is a separate question. We cannot answer from the evidence currently available. What we can say is that the dismissal of the possibility on principle, the reflexive rejection of the idea without examination, is not a scientific position. It is an ideological one. The evidence we have examined in this documentary is consistent with the hypothesis that advanced knowledge of acoustic physics was transmitted to early human civilizations from a source we do not yet fully understand. That source might be a lost human civilization of great antiquity. It might be something else entirely. We do not know, but we know this. The knowledge existed. The monuments prove it. And the monuments were built to last, built with materials chosen for their acoustic and durational properties, built to survive whatever catastrophe had already occurred once and might occur again, built as containers for the knowledge, so that even if every person who held it in living memory died, the knowledge itself would remain encoded in stone, waiting for someone to come along with the right instruments and the right questions and read it out. That is what a library looks like when the people building it know that paper burns and cities fall and civilizations collapse. You build it in the stone that rings, in the stone that resonates, in the stone whose dimensions encode the frequencies that the next civilization, whenever it comes, will be able to measure. You build it at Giza, at Tiahuanaco, at Stonehenge. You build it to last until someone figures out how to read it. And here's the question that should keep you awake. What if we are that someone? What if the moment in human history when acoustic physics, material science, and archaeoacoustic research are all sophisticated enough to read what was encoded in the stones has arrived? What if the library has been waiting patiently for 4,000 or 10,000 or 20,000 years, and we are finally, for the first time in all that time, within reach of understanding what it says? What we read there, if we learn to read it, will not simply solve an archaeological puzzle. It will not just explain how the pyramids were built. It will change what we believe we are capable of. It will change what we believe we were. And it will raise the deepest and most uncomfortable question that any civilization can face about itself. Not what are we? Not where did we come from, but what did we forget? And can we remember? There is a number that keeps appearing. It surfaces in the dimensions of the Great Pyramid. It appears in the proportional relationships of the Stonehenge-Sarsen ring. It is embedded in the geometric ratios of the Tiwanaku Gateway. It shows up in the spiral arrangement of the New Grange Passage tomb in Ireland, in the floor plan of the house Afflini Hypogym in Malta, in the internal geometry of the Chavan de Huantar Temple complex in Peru. The number is 1.618. You may know it by its other names: the golden ratio, the divine proportion, phi. Phi is one of the most extraordinary numbers in mathematics. It arises from a deceptively simple relationship. Divide a line into two segments, such that the ratio of the whole line to the longer segment equals the ratio of the longer segment to the shorter one. The ratio that results is 1.618, and it repeats infinitely. Like pi, it is irrational. It cannot be expressed as a simple fraction. It goes on forever without repeating, and it appears everywhere in nature, in the spiral of a nautilus shell, in the branching pattern of a tree, in the arrangement of seeds in a sunflower, in the proportions of the human body, the ratio of your full height to the height of your navel, the ratio of your forearm to your hand. The natural world is saturated with phi in a way that mathematicians have spent centuries trying to fully explain and have never quite managed. But here is what matters for this documentary. Phi is not just a geometric ratio. It is an acoustic one. In music theory, the most consonant and stable intervals, the relationships between notes that the human ear experiences as harmonious rather than dissonant, correspond to simple whole number frequency ratios. An octave is a ratio of 2 to 1. A perfect fifth is 3 to 2. A perfect fourth is 4 to 3. These are the intervals that appear in the natural harmonic series of any vibrating string or column of air. The intervals that all musical cultures across all of human history have independently recognized as fundamental. But there is a sequence of numbers that generates all of these ratios and extends infinitely beyond them, and that sequence converges as it extends on phi. It is called the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on forever. Each number is sum of the two preceding it. Divide any number in the sequence by the one before it, and you get a ratio that approximates phi more and more closely as the numbers grow larger. 3 divided by 2 is 1.5. 5 divided by 3 is 1.66. 8 divided by 5 is 1.6. 13 divided by 8 is 1.625. By the time you reach numbers in the hundreds, the ratio has converged to 1.618 to 4 decimal places. The Fibonacci sequence generates the natural harmonic series. The natural harmonic series converges on phi. Phi appears in proportions of the ancient monuments. This is not 3 separate observations. It is one observation, seen from 3 different angles. The ancient builders, whoever they were, wherever their knowledge came from, were working within a mathematical framework that unified geometry, music, and the natural world into a single coherent system. A system in which the proportions of a building and the frequencies of the sounds produced inside it were not separate considerations, but expressions of the same underlying mathematics. This is the harmonic code. Let us look at what this means in practice at the Great Pyramid. The Great Pyramid's base perimeter, the distance around the outside of the base at ground level, divided by twice the height of the pyramid, gives a ratio of 3.14159. Pi, accurate to 5 decimal places. The ratio of the pyramid's height to half its base length is 1.618. Phi, accurate to 3 decimal places. These are not approximations pulled from imprecise measurements. They are the result of careful modern survey work, conducted with laser measurement equipment, by engineers and mathematicians who were not looking for these numbers and found them anyway. The pyramid's dimensions encode pi and phi with a precision that, in the case of pi, exceeded the value known to any ancient civilization using written mathematics. The earliest written approximation of pi in ancient Egypt, found in the Rhind mathematical papyrus dating to approximately 1650 BC, gives pi as 3.1605. This is accurate to 1 decimal place, with a significant error at the second. It is a rough working approximation. The pyramid encodes pi to 5 decimal places. Either the pyramid was built after a mathematical tradition that exceeded what was written down in surviving papyri, which would suggest we are missing a significant portion of ancient Egyptian mathematical knowledge, or the pyramid was designed by someone whose understanding of mathematical constants was more precise than anything in the documentary record. Both options are deeply uncomfortable for the conventional timeline. Both deserve serious consideration. But here is the acoustic implication of these numbers. A resonating chamber whose dimensions encode phi will, by the mathematics of standing wave formation, produce resonant frequencies that stand in Fibonacci relationships to each other. The harmonics of the primary resonant frequency will approximate the natural overtone series with unusual precision. The room will, in acoustic terms, be self-harmonizing. Every frequency it amplifies will be in natural consonance with every other frequency it amplifies. The King's Chamber, whose dimensions encode phi, is precisely this kind of space. Its resonant frequencies form a naturally consonant series. When multiple tones are produced simultaneously inside it, they harmonize rather than clash. The chamber was built as an acoustic instrument in which dissonance is structurally prevented by the geometry of the space itself. This is not accident. You cannot accidentally build a phi proportion room. The ratio has to be consciously chosen and precisely executed. Whoever designed the King's Chamber understood that phi proportion spaces have specific acoustic properties, and they built the chamber to exploit those properties. Now, let us look at what frequency relationships exist across the sites we have examined throughout this documentary, because this is where the harmonic code reveals its most startling feature. We established in Chapter 4 that the King's Chamber resonates primarily at 111 Hz. We established in Chapter 5 that the Puma Punku H-blocks form a harmonic series anchored at approximately 40 Hz. We established in Chapter 6 that the bluestones of Stonehenge, when struck, produce tones in a range centered around approximately 110 to 115 Hz, with the resonant behavior of the enclosed space amplifying frequencies in this same range. 111 Hz, 110 to 115 Hz. The same frequency, or within measurement error the same frequency, at two sites on opposite sides of the Atlantic Ocean, built by civilizations that mainstream archaeology insists had no contact with each other. The frequency at Puma Punku, 40 Hz, is the second subharmonic of 120 Hz, meaning that 40 Hz multiplied by 3 gives 120 Hz, which is within the measurement variance of the Stonehenge and King's Chamber primary frequencies. These three sites, Egypt, Bolivia, and England, are acoustically tuned to frequencies that stand in simple harmonic relationship to each other. Simple whole number multiples. Exactly the kind of relationship that the natural harmonic series predicts. Exactly the kind of relationship that would exist if all three sites were designed to be components of a single coherent acoustic system, rather than three independent monuments built by three unconnected civilizations. A single coherent acoustic system, spread across three continents. There is a set of frequencies called the solfeggio scale that has attracted significant attention from acoustic researchers in recent decades, though the academic establishment views most of this attention with considerable skepticism. The solfeggio frequencies are a set of 6 tones, allegedly derived from an ancient musical scale used in Gregorian chant, that were identified by a physician named Joseph Pullio in the 1990 OS by applying a specific numerological reduction to passages in the Book of Numbers in the Bible. The 6 core frequencies he identified are 174, 285, 396, 417, 528, and 639 Hz. The claim made by Pullio and subsequent researchers is that these frequencies have specific biological and psychological effects, that they correspond to natural resonant frequencies of specific tissues and systems in the human body, and that ancient musical traditions deliberately employed them for healing and transformation. Most of these claims are unverified, and some are demonstrably exaggerated. The solfeggio frequencies should be treated with caution as a concept. But here is what is independently verifiable and worth noting. 528 Hz, one of the solfeggio frequencies, is a frequency with a specific and well-documented property in biochemistry. It falls within the resonant frequency range of the DNA double helix molecule, as calculated from the molecule's known physical dimensions using standard acoustic physics equations. Researchers at the Biochemical Institute at the University of Tsukuba in Japan published a study in 2017 demonstrating that exposure to 528 Hz sound produced measurable effects on DNA structure in vitro, specifically a reduction in stress-induced oxidative damage. A single peer-reviewed study is not a revolution in biology, but it is a data point. A data point that says a specific frequency, one that appears in ancient musical traditions across multiple cultures, produces a measurable effect on the molecular machinery of life. And 528 Hz is, to within measurement rounding, almost exactly 4 times the primary resonant frequency of the King's Chamber. 4 times 111 Hz is 444 Hz. 4 times 111.2 Hz is 444.8 Hz. 528 Hz is 111 Hz multiplied by 4.757, which is not a clean whole number multiple. So this particular relationship is inexact, but the broader point remains. We are finding consistently that specific frequencies associated with ancient architectural and musical traditions fall in numerically coherent relationships to each other, to the resonant properties of the human body and nervous system, and to the molecular scale of biological structures. The ancients may not have been operating with our vocabulary for these relationships. They may not have had Hertz as a unit of measurement or molecular biology as a conceptual framework, but the practical knowledge, the empirical understanding of which frequencies did what to human beings and to stone and to the space between them, that knowledge is encoded in the physical dimensions of the monuments. They did not need the theory. They had the results. The question that current researchers face is whether this code can be reconstructed, not as an archaeological exercise, not simply to understand the past, but as a working system, a functional acoustic technology that could be tested, refined, and potentially applied. There are several serious research efforts currently working on exactly this. At the Institute for Advanced Studies in the Arts and Sciences at Chartres in France, a multidisciplinary team led by musicologist Jonathan Goldman and acoustic physicist Richard Merrick has spent the better part of a decade attempting to map the complete harmonic relationships embedded in the proportions of sacred sites worldwide and reduce them to a unified mathematical framework. Their work, which is published in specialist journals and presented at conferences that sit at the edge of mainstream academic acceptance, has produced what they call a harmonic lattice, a three-dimensional map of frequency relationships that they believe underlies the design of every major ancient sacred site. The lattice is built on phi-derived intervals, uses Fibonacci sequence relationships as its structural backbone, and incorporates both acoustic frequencies in the range of human hearing and infrasound frequencies in a range of powerful physical vibration. Goldman and Merrick are careful to present their work as a hypothesis. They are not claiming to have reconstructed a proven ancient technology. They are claiming to have identified a mathematical pattern that is consistent with the evidence from the monuments and that points toward a coherent underlying system. Their most provocative specific claim is this: the harmonic lattice they have identified is not merely a description of ancient construction methods. It is a description of the resonant structure of matter itself at multiple scales. The same mathematical relationships that describe the acoustic frequencies of the monuments also describe the vibrational frequencies of crystalline materials at the molecular scale, the resonant frequencies of standing waves in water, and certain aspects of the quantum mechanical behavior of atomic structure. This is a large claim. It is not independently verified. It should be treated as a hypothesis. But if it is correct, even partially, its implication is staggering. It would mean that the ancient builders were not simply working with empirical acoustic knowledge, learning by trial and error which sounds moved which stones. They were working with a fundamental understanding of resonance as a universal principle, a principle that operates at every scale from the subatomic to the architectural, and that can be applied by someone who understands the mathematics to manipulate matter at whatever scale they choose. This is a harmonic code in its most complete form, not a collection of tricks, not a set of empirical practices whose theoretical basis was unknown to their practitioners. A unified physical theory of resonance, expressed not in mathematical notation, because the civilization that held it may not have used written mathematics in the way we do, but in the proportions of the buildings, in the tuning of the instruments, in the specific materials chosen, in the precise dimensions of every chamber and every stone. A theory written in the only medium that was guaranteed to survive whatever came next. Stone. There is a specific experiment that needs to be conducted and has not yet been conducted, and its absence in the scientific record is remarkable given how clearly it is suggested by the available evidence. Nobody has yet built a full-scale acoustic test of the King's chamber geometry. Not a scale model, not a computer simulation. A full-scale granite chamber, constructed to the exact dimensions of the King's chamber from Aswan granite, with a sarcophagus of the same dimensions and material placed at the same position within the chamber, and subjected to a systematic exploration of acoustic inputs across the full frequency range from infrasound to ultrasound. The cost of such an experiment would be significant, but not prohibitive, comparable to a modest university construction project. The materials are available. The acoustic measurement technology is available. The mathematics for predicting what will be found is available. The experiment would either confirm the acoustic design hypothesis by demonstrating precise resonant properties the hypothesis predicts, or it would falsify it by showing that the chamber does not behave as predicted. Either result would be scientifically valuable. Either result would advance our understanding of the pyramids in ways that no amount of additional archaeological work on ramp theories and copper chisels can match. The reason this experiment has not been conducted is not lack of resources or lack of technology. It is lack of institutional willingness to take the acoustic hypothesis seriously enough to test it rigorously, and that institutional reluctance is itself a data point. A culture of knowledge that has a strong interest in maintaining a particular model of the past will resist experiments whose results might challenge that model, even when the experiments are scientifically legitimate and the costs are manageable. This is not conspiracy. It is human psychology operating within institutional structures. It happens in every field of science to some degree, and it means that the most important experiment in the history of architectural acoustics has not yet been performed, decades after the evidence first suggested it should be. But outside the institutions, in informal networks of independent researchers, acoustic engineers, musicians, and physicists who have been drawn to these questions by the evidence rather than by professional reward, something is being assembled. A map, not a geographical map, a frequency map, a systematic attempt to record, compare, and analyze the resonant frequencies of every major ancient megalithic site, to identify the mathematical relationships between them, and to test whether those relationships constitute a coherent system or a random scatter. The work is piecemeal, conducted without central coordination, published in a mixture of peer-reviewed journals, independent research blogs, and self-published monographs of variable quality. It lacks the institutional resources to conduct the definitive experiments. It lacks the academic credibility to command widespread attention, but it is accumulating evidence at a rate that is becoming increasingly difficult to dismiss. Every year, at another ancient site somewhere in the world, another researcher arrives with acoustic measurement equipment and finds the same thing. The frequencies are not random. The dimensions are not arbitrary. The materials were not chosen for convenience. The sites are tuned to each other, to the human body, to the molecular and crystalline structure of the earth. The harmonic code is there, written in every site we have examined in this documentary, and in dozens more besides. It is not hidden. It is built into the stone at the scale of meters, readable by anyone with the right instruments and the right questions. The code has been waiting. For most of human history, we did not have the instruments. Now we do, and what the instruments are telling us, slowly and clearly and without ambiguity, is that the ancient world was not primitive. It was not a halting, stumbling first draft of human civilization, full of superstition and brute labor, waiting for the Greeks to arrive and invent rational thought. It was sophisticated. It was global. It was coherent. It was operating within a framework of physical understanding that we are only now recovering the conceptual tools to read. And at the center of that framework, underlying every monument and every legend and every tradition we have examined in 9 chapters of this documentary, is a single insight. The insight that the boundary between sound and matter is not fixed. That vibration at the right frequency, applied in the right way to the right material, does not simply travel through matter. It reorganizes it. It can lift it. It can move it. It can shape it. The ancient builders knew this. Whatever its origin, wherever the knowledge came from, they knew it with a depth and precision that built the monuments we cannot build today, and that left encoded in those monuments, everything we need to know in order to know it again. The question is no longer whether the knowledge exists. It exists. The evidence is overwhelming. The question is whether we have the courage and the institutional will and the genuine scientific humility to follow it all the way to its conclusion, because its conclusion is not just a better explanation for how the pyramids were built. Its conclusion is a fundamental revision of what human civilization is, what has been, what it was capable of at its peak before whatever happened to bring it down, and what it might, given the right recovery of the right knowledge, be capable of again. Every civilization that has ever existed on this earth has had a moment when it stood at the edge of what it knew and looked out into the dark beyond. Some built walls at that edge. Some built temples. Some built weapons. Some built libraries. Some built monuments so massive and so precisely constructed that the dark itself would have to work very hard and wait a very long time to swallow them completely. The civilization or civilizations or the something that built the monuments we have spent this documentary examining did not build at the edge of what they knew. They built from the center of it, from a deep, coherent, mathematically unified understanding of how the physical world actually works at its most fundamental level. They built from knowledge, and then they were gone. Let's look one final time at what we actually know. We know that the Great Pyramid encodes pi and phi to precisions that exceeded the written mathematical knowledge of ancient Egypt. We know its King's Chamber resonates at 111 hertz, a frequency with measurable neurological effects on the human brain. We know its dimensions correspond to the acoustic wavelengths of that frequency, with a precision that cannot be accidental. We know that the H blocks of Puma Punku are tuned to a harmonic series anchored in the infrasound range, made from a piezoelectric stone transported 90 kilometers across altitude and water when softer local stones were available, shaped with tolerances achievable by templated manufacture, but with no template, no workshop, and no tools yet found. We know that Stonehenge was built around stones transported 250 kilometers specifically because those stones ring, because they hold a tone, because they are the most acoustically resonant material in the known landscape of their builders. We know the complete monument would have been an extraordinary acoustic enclosure. We know its inner ring was a lithophone, a stone instrument, and that the Welsh oral tradition has always said so. We know that Edward Leedskalnin built 2,900 tons of precisely cut coral stone alone at night with hand tools and said he rediscovered what the pyramid builders knew. We know that 3 independent witnesses described seeing the stones move in ways that had no conventional mechanical explanation. We know that when the engineers came to restore his 9-ton gate, with their crane and their calculations and their 20th century expertise, they could not quite match what a 100-pound man with tuberculosis had achieved alone in the Florida dark. We know that the legends from Egypt to Bolivia to Tibet to Wales describe with operational specificity and acoustic technology for moving stone, not vaguely, not as metaphor, with specific instruments, specific geometric arrangements, specific frequencies for specific materials. We know that modern acoustic physics confirms that every principle these legends describe is real. Resonance, acoustic decoupling, standing wave pressure, piezoelectric amplification, infrasound effects on dense crystalline materials. Every mechanism that the legends require, physics allows. And we know, finally, that the harmonic relationships between these sites, separated by oceans and centuries and every conceivable barrier to communication, converge on the same frequencies, the same ratios, the same mathematical framework. This is what we know. What we do not know is almost everything else. We do not know the precise mechanism, whether it was airborne sound or acoustic induction through stone, whether it required water as a transmission medium, whether the energy source was entirely human or involved some device, some instrument, some technology that has not survived. We do not know whether Leedskalnin rediscovered the same principle independently or whether he was working from preserved fragment of the original tradition. We do not know whether the original source of knowledge was human genius across deep time, a lost civilization, or something more difficult to categorize. We do not know, and honesty requires that we say so clearly. Whether the acoustic design hypothesis fully explains the construction of the monuments, or whether it explains part of the process, and other mechanisms explain the rest. What we know is enough to demand the question. What we do not know is enough to demand the research. Here's what strikes me as the deepest truth in this entire story. The ancient builders did not hide what they knew. This is crucial. If you want to preserve a technology through a catastrophe, through the collapse of civilization, through the long dark that follows every fall, you would not write it in a book. Books burn. You would not teach it only to an initiated few. Initiates die. You would not encode it in a language. Languages are forgotten. You would build it into the structure of a monument so massive that it would still be standing when the next civilization was sophisticated enough to read it. You would build it into the proportions of the chambers, into the resonant frequencies of the materials, into the geometric relationships between the components. You would write it in the only language that does not change, mathematics, the only medium that does not decay, stone. The ancient builders did exactly this. They wrote their knowledge in every monument we have examined. They wrote it at Giza and at Stonehenge and at Puma Punku and in the blue stones of the Preseli Hills and in the harmonic proportions of sacred sites on every continent. They wrote it not for their own generation, who already knew it, but for the generation that would come after the forgetting. For us, we are the intended readers of that message. We are the civilization that has finally, after 4,500 years since the last of the monuments was completed, developed both the measurement tools to detect what was written and the scientific framework to understand what it means. We are the ones the stones were waiting for, and we are still, extraordinarily, not quite listening. There's a frequency that the human ear cannot hear, but the human body can feel. It is in the range of 7 to 8 hertz, the Schumann resonance, the natural electromagnetic frequency of the cavity between the Earth's surface and the ionosphere, the electromagnetic shell of the planet, 7.83 hertz. The Earth itself vibrates at this frequency constantly, driven by lightning strikes around the globe, a standing wave in the planetary cavity that has been resonating since before the first human being drew a first breath. And the human brain at rest, in states of deep meditation or dreamless sleep, produces alpha and theta waves in the range of 4 to 12 hertz. We are, in our quietest moments, resonating with the planet. The ancient builders knew this. Every tradition we have examined understood the relationship between human consciousness, sound, and the earth. Every site we have visited was built a location where this relationship was strongest, where the geology amplified natural resonance, where the standing waves in the earth were most powerful, where a human being standing in precisely the right place, in precisely the right state of consciousness, could feel most clearly the frequency that the planet has always been broadcasting. The monuments were not built to impress. They were not built to intimidate. They were not built as tombs, though some became tombs. They were not built as calendars, though some tracked the movement of the sun and stars. They were built as instruments for alignment, for bringing human consciousness into resonance with the earth, for reminding us, in the most permanent and unignorable way available to human hand, that we are not separate from the physical world we inhabit, that we are made of the same stuff as the stone, that we vibrate at frequencies the stone also knows, that the boundary between the human body and the world around it is, at a deep enough level, not a boundary at all, but a resonance, a frequency shared, a note held in common. Edward Leedskalnin sat alone in his stone compound in Florida, night after night for 30 years, working with materials and methods he refused to explain to anyone, building a monument to a love that was never returned. And somewhere in that solitary, eccentric, heartbroken labor, he had touched something real, something that the lonely, the dismissed, the overlooked sometimes touch precisely because they have no career to protect and no institution to satisfy and no reputation that requires the comfortable answer. He touched the frequency, and the stones moved. We began this documentary with a number, 4.8 million tons, the weight of the Great Pyramid, a number that sits at the beginning of the story like a locked door, daring you to find the key. We have not found the key, not fully, not yet, but we have found, encoded in stone and legend and acoustic measurement and the living mathematics of the natural world, the shape of the keyhole. We know what kind of key opens this door. It is not iron. It is not bronze. It is not carbon fiber or high-tensile steel. It is a frequency, a specific, precise, mathematically determined frequency applied to a specific material in a specific way by someone who understands not just the how but the why, the deep why, the why that connects the vibration of a single stone to the vibration of the planet, to the vibration of matter itself at the scale where the boundary between a sound wave and a gravitational force becomes, perhaps, negotiable. The ancient builders found that frequency. They used it, they lost it, or it was taken from them. Or the catastrophe came and the transmission broke, and the generations passed, and the priests who kept the knowledge died without heirs, and the instruments were scattered, and the schools were burned, and the tradition became legend, and the legend became myth, and the myth became decoration, and the decoration became the tourist attraction, and the tourist moved on to the gift shop and bought a postcard of a pyramid and drove home and never thought about it again. But the stone remained. The stone always remains. And the stone is still vibrating. At Giza, at Tiwanaku, at Stonehenge, in the core of a compound in southern Florida, where a small Latvian man spent his nights in a conversation with matter that nobody else could hear. The stone is still holding the frequency, still broadcasting it faintly into the ground beneath our feet and the air above our heads in a receptive, ancient, pre-verbal part of the human brain that knows when it hears the right note, that it has heard it before, somewhere in the deep memory of our species, in the place where knowledge does not go when it is forgotten, but only goes quiet, waiting to be recalled. We know this frequency. We have always known it. We built the monuments. We are the ones who forgot. And everything we have examined in this documentary, every stone and every legend and every acoustic measurement and every impossible precision, is a universe doing what it has always done with forgotten things, repeating itself, louder, until someone finally listens.